Hey there, Inspector. We are working on getting the stuff set up. It doesn't show me on YouTube yet, but I have it all set up, so I'm really just trying to get right now and figure out what's going on there. Once I get that going, we should be just about ready to move on with this other stuff. Yeah, Inspector, you're right on time. Alright. We'll be getting on here. I'm trying to see why it won't allow me to connect. Paste into my encoder, but I shouldn't need that because I'm set up. Well, maybe it's not going to let me stream live to YouTube, even though I thought I had that all set up. Alright, well, let's see what we're working on here today, and we'll see if this YouTube thing is happening today or not. If it's not, we will go a different route. I don't know why I would need any of this, because I'm already set up to be streaming in there. So and kind of annoying if I can't get it to go over there live like this. Well, I guess give me a second here, guys. We'll see if I can get this going. Hey, how's it going, White223? Give me a second real quick. I'm trying to get my stuff streaming over on YouTube, which it absolutely should be all working. Time. Hopefully this stuff's useful to you. Robodom's here too. That's good. Well, let me see if I can't get this. That's weird. It's not letting me do the thing I want to do. I don't have added delay on. I don't have any of that stuff on. That should just work over there. Ryan, yeah, thanks for showing up. Hopefully this is useful. Robodom, yeah, your attendance record, it's bad. But we got no attendance record for you. I don't know why. It says I'm live, but it's not getting. Oh, there it is. All right. I'm gonna say that we're live over there, so that's good. Okay, yeah, I'm on YouTube as well, Robodom. All right, give me a minute. It looks like it's definitely linked up over there, and that's cool. And then I'm also linked up over here. All right, good. All right, so give me. It's a YT, but it'll I think that gives you our actual YouTube channel. Let me click on that and make sure that works. Yeah, that works over there too, Robodom. Yeah, I think you guys, I wouldn't watch on both, but you guys are welcome to. Maybe you can even be the first chatter over there, Robodom. I don't know. There, I'll be the first chat over there. Nope, it looks like our other guy was. Yeah, no, I know who you are, Robodom. But you're still technically the first because I don't count talking to my own chat. All right, give me 1 second, and here's what we're going to do today. So we got a few different things that we work on, but let me show you guys kind of what I have, I guess, planned, if we will. Oh, whoops. No, that's the wrong one. It's this one now. So we're going to talk a little bit about learning Linux and the way that we learn. I'm going to probably start a little bit of a series here called like learning through the Socratic method, which is just a way to learn, right? It's another way to learn, and I'm going to ask you some questions about different system stuff as we go, and I'll keep adding to these questions as we go. But it's going to be around how to learn Linux, right? How do we get better at doing this stuff? How do we learn how to learn systems and those kind of things? And let me see if I can move. I cannot see. It doesn't seem like they're gonna tell me over here. Hold on. I'm trying to move around this other chat. Give me a second here, guys. Yeah, I need to know how many okay, so it's just 2 of us over here on there. Okay, I just wanted to see if it was going to tell me the number of participants anywhere on the Linux side of things. There's Inspector, and yep, we're still talking here, and we'll get started here in a second. In the meanwhile, keep an eye on Ranger Dog. What's Ranger Dog up to? He's laying around being a dog. It's cooling down in Phoenix pretty big, so that's getting better. I can see all my chats, I think, so yeah, let's get into this here. We'll get into Linux here in the next couple minutes, all right? Do some do some command line. Oh, I did a lot of Ansible today. I did a lot of writing stuff, a lot of getting stuff worked on, so we'll talk about that a little bit. And I'm going to pop these different things up, I think, as we go, for you guys to think about these different things. And hopefully it doesn't look like this the whole time, right? Also, I'm doing that to see what my delay is on YouTube. Looks like my delay is, I don't know, over 15 seconds now. All right, I'll drop that. See how long my delay is here. I'm kind of curious how long it is. I mean, it doesn't really matter that much, but there's a little bit of additional time there. Oh, probably about 20 seconds of delay. All right, so that's good. So give me a second, and then we'll get started here. I'll make that a little bit bigger. Good. All right, and give me a second. We'll get started here. All right. Alright. Also, do I gotta need to fix my little thing at the bottom of the screen? Give me a second here. I think I gotta fix that thing too. Probably should have been a little more. Yep, it's Monday night. Monday afternoon. Alright, there we go. Save that up. And let's get going. Alright. Now, the thing is, I don't think you guys can see each other across chat, and I'm not probably gonna ever fix that because don't care. What's Ranger looking at? Ranger's like all focused and stuff right now. But yeah, let's get into this. Let's do a little bit of Linux here. So we have a bunch of labs that are available. They are in our Killer Coda site. So Killer Coda is a free site that anybody that hasn't been around can get into. And we're going to go ahead and just go to Linux, and we'll do, it doesn't really matter which one we hop into, because the questions I'm going to ask you are going to be general around all of systems. We're not going to be dealing with any one of these particular labs for right now. So let's just hop into the first one. It doesn't really matter which one we do, although I am going to order these, and the ordering will be better. So I'll go ahead and pin the message over here on the Streamlabs or on the Twitch side, and then I'll send it over here as well for people that want to see what's going on the YouTube side. And then if anybody wants to test over there how that's working, feel free to. I think that's maybe a valuable thing to look at and get into. All right, I'm going to pop this up, and the question here for today, or the thing about it is, we have a lot of different ways that we learn, right? And as somebody who has to teach people often, I have to think about different ways that people learn. So the way that I'm going to kind of walk us through things today is going to be doing something that is often called the Socratic method, right? The Socratic method is a method of teaching where the instructor or the person that's talking asks a series of questions, typically sometimes rhetorical and sometimes not, to make the user or the learner think about things. All right, so I'm going to walk you guys through a little bit of this, and we're going to start just walking through Linux by asking ourselves a bunch of questions. All right, I put some of the questions together. I'll ask some of the questions and add to this as we kind of go. So let's see, kind of on CPU topics. These are things that I've been going over a lot lately, but this can kind of be for you, since you don't have a way to directly talk back to me. This is a way for you to maybe sit and reflect and think, hey, do I understand these things? Do I know a bunch of these things that he might be asking? I've got a basic little Linux system here that I'm connected into. Anybody could be connected into the same Linux system as me if they wanted to, and we're just going to go through this, all right? So the first one, we'll talk a little bit about CPU topics. And the first question is, can you list the number of CPUs? How would you go about doing that? How would you go about listing the number of CPUs in a system if you needed to? You guys can do them yourself and answer them. You can also go ahead and just go ahead and type it in chat if you want to as well. I don't care. But how would you list the number of CPUs? You're going to be in an organization, you're going to get called out, and they're going to say, well, the documentation says this server is this, is the server that, and you have to go verify that. This is something we do in, an incident call. This is something we do when we, put a server in for the first time and start building it. We just need to know how many numbers of CPUs are there. Do we know how to do that? And that's a simple little thing for some of us that have done this more, but for others of us, it may be something that causes us to lock up, right, and think about. So how do we list the number of CPUs in a Linux box? Who knows? Could we do nproc? That's a good one. How about catproc CPU info? Would that tell us that? That would give us the number, wouldn't it? It would give us the first one, which is 0, and no other ones, so that would be it. Okay. So that's something to know on a system. How can I tell how many processors are on a system? And nproc is probably one of the easier commands. Catproc CPU info can also be a command. And if we had a system that had more CPUs in it, could we figure it out quickly with some of these different commands? Could we figure out that everything in there, was behaving a certain way? I don't know. There's a bunch of other info we get from catproc CPU info. Could I take this and could I parse this down to just be the information I want? Yeah, I can make that come out with the same information if I want, right? So again, we're back here, we're talking through, and we're doing a little bit of what's called the Socratic method, where you start a dialogue and think about things and think through how you learn something. So CPU topics, my first question was, can you list the number of CPUs in a Linux system? And, that's pretty common to know how to do. You've never been on a server before. Can you list how many CPUs on there? How confident are you that that's the right answer? All right. Hey Greg, how's it going? We're actually streaming for the first time ever on YouTube as well. And oh yeah, we got people answering on YouTube, so that's good. Yep, Leith is saying LSCPU. Yeah, LSCPU is valid too, right? That's a valid way to see kind of what's going on in the system as well. How many online CPUs and cores there are. Yeah, that's a good one as well. There's your number of CPUs right there. Good. I didn't even think to use LSCPU. There's another one. So there's more ways than one, right? There's this old saying. If you guys have never heard me say it, Tim Towdy, there is more than one way to do it. Oh, I think there might be a Tim Towdy. There's more than one way to do it. That's how people sometimes spell that. It's harder than it seems, though, because hyperthreading in one core show up as two CPUs makes things confusing. MoonPie, that is absolutely true. Oh, hold on 1 second, guys. I got a call from the wife. All right, sorry about that, guys. I think the wife just needed to talk to me real quick because she's on the way home. Yeah, it's Tim Towdy, Robodom. Yep. There is more than one way to do it, is what that means. And that's a thing that we used to say often. I saw the dashboard and couldn't get through the ads quick enough. Yeah, Tim Towdy is there's more than one way to do it. All right, so we found a few different ways. I'm not going to list them all out here, but I want you guys to kind of sit and think about it, right? Can I list out the number of CPUs in a system, right? Then the next one here is, can you tell me the speed in megahertz, right? So that system that you're on is going to operate at a certain speed. And can you tell me what that speed in megahertz is? You know, some of those commands are the exact same commands, right? Some of those are the same when we did our LSCPU. That's going to be some of the same commands to get the speed. So maybe megahertz and then also CPU info. So catproc CPU info may be able to give us the speed in megahertz as well. Okay, that's good. But nproc can't do that for us, can it? No, nproc can't tell us that kind of information. But we can get that from here. What if I told you there was another tool that I might be able to get to work? I might be able to try a DMI decode. I'm not even sure what this all will give me. DMI decode will give you a lot of information. And let's grep-i for MH. And let's see, yeah, there's some information that's coming out of DMI decode. That's not as precise as what we were getting out of these other ones, right? And I'm going to tell you guys another thing that you might have never thought about. It's also good, like if you're watching me do this stuff, it's a good thing, NeoFetch. I don't know if that's a real command or not, but that's interesting. A lot of times with engineers, it's a good thing to look over our shoulders and watch us do things. So you watch me do something, and then you see like, oh, hey, that's kind of interesting. I never thought to do the grep-i, or you know, you see some other way of an engineer doing it, right? So I try to get you guys to think about, you know, if you've ever done pair programming or pair engineering with other engineers, it's a good practice to like look over somebody's shoulder and figure out how these things work. Oh, I didn't even think about that. Hold on, let's see HW info. It's not there. So it's not there on all systems. And I imagine this isn't either. Yeah. And I doubt that is too either, right? So there's other commands that are out there, but not all tools are on all systems. And this is actually another important thing to understand as a systems engineer and administrator. Not all tools are on all systems. It's one of the reasons that I tell people to learn the more command. The less command came much later, and more is on all old Unix, AIX, and HPUX systems. But less isn't always there. So there's different commands that you may or may not use depending on where you're at. Did some pair programming a while back, was very helpful. Yeah, Robodom, I can't tell you how many times I've learned stuff. Like even with just old engineers, they'll watch me or something. They'll be like, hey, what was that thing you just did? And I'm like, oh, I just did this thing. And they're like, oh yeah, I had never seen it that way before. And then like you learn things. You also just do pager. I wonder if pager works. I don't know. Yeah, I don't know. Oh, to see if something's there. I'm not sure, MoonPie. So that's, can you tell me the speed of megahertz? So yeah, the answer is yes. We could do a bunch of these different commands and get pretty close to the actual speed of our system. All right, that's good. That's good. Because remember, at the end of the day, when you look at a system, you are literally just sitting here at a blank terminal. If you don't know what to ask it, it's not going to do anything for you. You've got standard input, and you get standard output and standard error. Those are the only three things that happen at a terminal, right? Input, output, and error. So we've got to figure out how to do this stuff. So one of these other things, page doesn't work on my Arch system, but it is more or less dependent on what is installed. Okay. So can you tell me the manufacturer of this CPU? So you're on a system like this. Can you tell me the manufacturer of the CPU of the system that we're in? What's some things that we might need to let's see if we can figure that out. CPU info. That tells me that it's an Intel Xeon Sandy Bridge. That's good. How about LS CPU? Is that going to give me some of that information? Gives me the same information. Okay. That's being passed through. All right. We can also see the architecture. We can see a lot of information here, right? Let's see. The next one takes us right to the memory topic. So I'm going to have to go in. I'm going to have to add some more of these now, right? And I'm just going to go ahead and duplicate this slide. And on the next slide, I'm going to say, can you tell me the architecture? Can you tell the architecture of this chip? Right? Can you tell me the architecture of this chip? That's the next question. And there's the architecture right here. It's an x86-64, which is a very common type of Linux architecture, right? What's another one? We were talking about this the other day. In the top 500, which are the top 500 supercomputers, that Fugakaru or whatever it is out of Japan is number 2 in the world right now after debuting 3 years ago. It's still number 2, and I told you guys that it is an ARM-based architecture. So it has it's an ARM 64. Yeah, it's on the 500. If you go to the top 500 here, you go to the number 2 one, the number 2 machine. Actually, it may still be. I don't know. It might have been bumped. Let's see. No, it's been bumped. It's down to 4 now as of November. So these ones just came back out. But I can tell you that this one was number 1 or 2 all the way up in June of this year for 3 years. It was the number 1. And this is an ARM-based architecture. Okay? Yeah, this is an ARM 64 architecture right here. But the only one that was above it was this Frontier system, and Frontier has maintained number 1, but Aurora and Eagle have slid into 2 and 3. So they slid in between these systems. But look at what these systems had to do to beat it. It was at 7.6 million cores, and they had to go way over on the HPE system, Hewlett Packard Enterprise, right? They bought Cray. That's why they're in the game. HPE Cray, that's also, both of these are owned by Hewlett Packard now. Cray doesn't exist anymore. They were bought. But their branding is still kind of there on some of their systems. And then I don't even know this Eagle system one bit. Looks like Microsoft did it. Interesting. They're using InfiniBand NDR, which is a 400 gigabit per second system. That's a pretty fast. That's the fastest of the InfiniBand. I was just briefed on that the other day by NVIDIA in a high performance compute call. So yeah, that's super fast. Yeah, they're HDR here. NDR is slightly faster. HDR, you can get up to 200 gigabits per second on quad HDR, but they're at NDR, which is faster. HP doesn't exist anymore either, sort of. Yeah. HPE, yeah. All right, so that's something to kind of look at there. But so I'm saying, can you tell me the architecture of this? Yeah, I can see the architecture right there, x86-64. Why is that important? Because that lets me know that it's a 64-bit operating system. If it just said x86, which was valid. I mean, you can still download x86 packages. Those are your 32-bit packages, right? You could still put those on systems. Not a lot of people do that anymore, but you could. It's still something you could do. Yeah, Leith, I appreciate you coming by. By the way, I'm monitoring kind of 2 chats now, so there's different stuff going on. So we see all that kind of stuff, and we say, okay. Then let me ask. This is not necessarily a CPU topic, but it's kind of a CPU topic. Let's duplicate that slide, and let's say, can you tell me this system is physical or virtual? So the question then, the next question I'm asking, can you tell me, can I merge the chats with those tools? MoonPie, I think I can. I think I can probably. There's a thing called the Restream bot that I've seen people use, and basically all it does, I think, is take the YouTube chat and bring it over to Twitch. There's not really anything. There's not much going on. It's just Leith answering questions and pretty much getting the right answer over there on the YouTube side of things. So that's pretty good. But you're not really missing. There's not like chat over there. I think there's two of us in there. I don't even think Robodom's over there anymore. So it's fine. But it's yeah, it's just us in both areas kind of. I'm just streaming to both platforms because I can. It doesn't even really matter to me. It's my first stream over there, so I doubt it really matters in any way anyways. But I just kind of have it over there. Oh, and Robodom's still over there too. So I guess that's good. All right, so, we're looking at these systems. We're asking these questions. How can I tell if this system is virtual or physical? Can I look at it here and see it? I think I'm going to be outside the scope of these commands for me to figure out if the system is physical or virtual here. There are some custom chat clients that show the same interface. MoonPie, that would actually be. I might have to look into that. I might have to see if there's a thing that does that, or if there's something. Yeah, let's try the system detect vert. I've never tried that one, so let's see if this one works. System. Let's see. It says that this is KVM. That is one way to do it. I did not know how to do it with that. That is not how I do it. I use DMI decode. DMI decode grep-i for prod will typically tell you the product name, and then depending on your environment, like I used to work with Cisco UCS systems, and the product name would either be VMware or it would be UCS for us in our environment. So I would know very quickly what it was. Yeah, and you do need systemd install. I didn't know systemd detect vert. I think that's an excellent one. I think that's definitely something that people should use. Let's see if, I don't know much about this one. Let's see if there's a help or a man. So this will detect whether or not we're in a container as well. Okay. If we're in a VM. Whoops, -v. Okay. And then you could just run it obviously by itself as well. And it'll tell you. Let's see. What are all the types that it might be able to find? That's nice too. That's a nice little command. Yeah, look at all that. Docker podman, container other. You're running container D, it'll probably find it there. That's very nice, right? Only detect whether we're running in a namespace. That's nice. Whether we're running in a chroot environment or not. See, there's a lot of information you can gather out of this. That's a pretty good command. I've never used that one. That's pretty good. All right, so that's an excellent answer to this question. Then maybe I'll have these fly in as we build this up. Maybe this will keep adding more and more, and maybe I'll have it fly in with some of the answers. But I really like that systemd detect vert command. That's a good one. I will typically do stuff like, again, I'll do my DMI decode, and I'll look at that, and I'll be able to tell on the system here. I'm on an Ubuntu system, but I'm down here in Red Hat, right? Where's it at? And I can see that I am on a Red Hat 8.6 server, but I am up here in a Ubuntu system. So, and there's my family KubeVirt. So I know I could probably have looked for that as well, but I know that I'm also in a virtualization. Is this to run as the host or from the container? So Tani, we're just talking about the questions here that I'm kind of walking through. We started with kind of the Socratic method of learning. Like how do people learn? How do you get things to stick in your head? And sometimes as engineers, sometimes as we're first learning things, we learn well by asking questions. So I was asking, can you list the number of CPUs? Can you tell me the speed? Can you tell me the manufacturer? Can you tell me the architecture? And now we were down as, can you tell me if the system is physical or virtual? So that was a really excellent command. So DMI decode is how I've always done it, but I really do like this. I think this might be one that I put in my toolbox. And guys, this is why we do this. This is why we do this, right? Like, did you think that I was going to come on here and say, I have 20 years. I defy any of you to teach me anything. No, I knew somebody was going to show me something I didn't know today. That's how engineering works. If I could hold all this stuff in my head, then first of all, if this was a known set where everybody knew everything, they would just have AI do our job for us. But I'm going to tell you right now, I don't see AI doing systems engineering for quite some time, because there's just too many things. And we talk often about like solutions architect roles and these other things, and some of the guys that use the AI to help them and stuff. Well, they're really just learning language models, and they help you by going and searching things, and they invariably come to incomplete solutions or not fully correct answers, because there are nuances to this. There are things that come up that you need to know. It's not, if it was a known set, again, it would just work. And I tell people all the time, yeah, you can't teach me anything in secure people. Tani, I know a lot of engineers that won't do anything at the command line in front of you, and it's like, man, guys, we got to show each other this stuff, because this is how we learn, right? This is how we get better at this. So, all right. So I said, can you tell me if this system is physical or virtual? And I think we found out pretty quickly that this system was virtual, and I think that's awesome. Now, if you guys have any other CPU type commands that you might think would be useful, I can add them out. I'm going to actually probably ask in the Discord to give me some extra ones and questions and stuff. But let's go to memory topics. So let's go down here to memory. Oops, network memory topics. All right. So now the first question is, let's say, geez, can you tell me how much RAM we have? So that's my first question. Can you tell me how much RAM we have? Right? What commands are you doing over here? And I can think of quite a few of them, so I'm sure you guys can. What are the different? How much RAM do we have? So how much RAM do we have in this system? What are you guys doing for that? What kind of commands do you think would be useful for that? Oh, I learned this, but I learned the pager trick. I'm not sure what pager is. Is that another? We might not have pager on here. We have top. By the way, guys, top would tell you how much memory there is. There it goes. A lot of guys won't use top in a system that's high load, because it does add a little bit of load itself. I'm a big fan of free-m or free-h. That's good. Those are both good commands. They give you some different stuff. Did you know you could do a free-ht and it'll give you the total at the end as well, so it'll add it all up for you if you want. Tani, that's fair, but have you ever seen what your developers do to the system sometimes? I can tell you right now, Tani, I've seen more systems just that I feel like are getting kicked around and abused by developers when I go to them. Like, it's like I see like an animal that's getting beaten by somebody, and I have to like stand over it while the person's like trying to kick at it, and I'm like trying to stop them. That's how I feel sometimes with like these poor abuse servers that I run. But yeah, any of those commands. So let's do a history real quick. Free top is a great one. Free-m, free-h, free-ht. Did you guys know that you could just dump a bunch of information? I don't even know. I mean, like, guys, I'm not a big fan of looking at tools that are not human readable. But did you know you could just cat proc meminfo, and this will just dump a whole bunch of crap on you? But that's not really super readable, right? Like, I don't like showing you guys stuff that's like just dumping crap in your face. That's not great. But this is a readable, or this is a way to get that info. This is a way to get all the info on the system. Cat proc meminfo. But most of us, I'm gonna squish Ranger down a little bit, because Ranger's not being super interesting for the purposes of discussion today. So I'm gonna squish him down a little bit, and I'm gonna go back to that free-m or free-h right there. Those are good. I like those. Horror story about an OCI image with software that had a memory leak. Rather than fixing it, they set Kubernetes up to automatically kill the old pods and re-up new ones. MoonPie, I was in a very similar situation to that, except they were just using a script, a bash script, and they were just killing a container and rebuilding it. it was a container from some third-party, company that this dev team had paid for some stuff. I don't even know. Okay, so can you tell me how much RAM we have? Yeah, there we go. How much RAM we have, and as a sub question to that, let's say, let's duplicate this side. So how much RAM we have? Can you tell how much RAM we have used? Right? And then can you tell me how much RAM we have free? And these questions might seem a little silly. You're like, oh, are you really going to make us look at the same thing 3 times? Yeah, because what if you, certain people learn differently, guys. Some people have to hear it. Some people don't look at this stuff and think about it. They have to be shown each individual piece, right? So again, I'm not trying to crap on how anybody learns, but everybody learns different, guys, right? And some of us, we got to do it. And it not going to need that one. What's the difference between free and available? Free. Where are you seeing available? Oh, available over here. Yeah, so available is, I believe that's cache minus free. Does that sound right? If we look at that, is that math looking good? I don't know. It's you might have to read up on all the things. I really only look at these 2 over here, or these 3 over here. How much do I have total? How much do I have used? And free is really the one that I care about for the most part, to know if I can do something on a system. So now let's get a little. Actually, you know what? I can answer that question in a second here, Skull Crusher. I can give you a better answer for that here in a second. Let me ask this one. So I'm going to do a little harder one. So can you tell me how much RAM we have free, right? And then can you tell me how much swap we have? Yeah, we have swap, right? Okay, so boom, we know how much swap we have. And then I'm gonna ask one that's gonna get a little harder here. This will be a little more advanced, but this is why we have this, so some of our more advanced engineers can tell. Can you free all of the cache memory? Does anybody here know how to free all of this buffer cache in case something happened? And by the way, so I'm going to tell you guys why I would need to free the buffer cache, or why I have over the years. You've got a team, you're working with one of your dev teams. This is their Ubuntu server, and the dev team comes to you and they say, hey, we need to, we've killed the process off. So you do a ps-ef, there's no more Java running, right? Java's dead. But that buffer cache has not cleared, which was all the stuff that they had. And you're just like, damn it, Java. And you're just shaking your fists at the heaven like I always am with Java. Because we can't really see what's going on inside the Linux system that we're dealing in. So we ask our users, we say, hey, or they ask us, they say, hey, can you clear that buffer cache? Does anybody know how to do that? All right, so I'll tell you guys here the answer in a second, but I'm going to see if anybody has it. Moonpie said, I use the magic sysrq keys to activate the myself, in which there's 2 versions rather than the kind of roulette one, the one that kills processes using the most memory. Yeah, I try to get rid of, out of memory killer has only ever caused me problems in all the 20 years I've seen it. So there's that. Free is physical memory that is free and available, how much you can request without causing any swapping. Interesting. Could be wrong though. Could just already include in memory. All right, Tomato, my man. Available estimation of how much memory is available for starting new applications without swapping. I'm guessing something in Proxys can be sent to messages. Yeah, so how do we clear out the buffer cache? We can echo. You can do 1 or 2, it doesn't matter. Drop caches. If we do this real quick, I'm gonna put a comment in front of this. If anybody wants to do this in their system, I'm gonna link this to you guys. I'm gonna put that command in there for you. And before I do this command, I'm just gonna hit it so it's in my buffer. I'm gonna go back up here and I'm gonna look at free-h. I'm gonna execute this, and then I'm gonna look at free-h again. Oops, free-n, right? And do you see that my buffer just wiped? My buffer cache just wiped. Now if I do a free dash M again, it's going to slowly fill up, but I killed everything that was out of there. So echo 3, you can also echo 1 or 2 in there as well, but they're going to do different things. Echo 3 is kind of like your nuclear option. You're kind of just dropping a hammer on it, and you're killing it. So procsys VM drop caches, and when you do 3, you drop everything. So there's you can go look up what is actually going to happen when you hit that. There's a 1, a 2, and a 3 you can send in there. 3 is the most catastrophic. So typically what we do is we don't execute this right here like I just did, unless we either 1, really don't care what's in there, or 2, we've been told by the team, hey, we killed everything and it's dead, so there's nothing that should be in buffer cache on the system that we care about. That's typically how I do it. Like if the Oracle team, like the database team, comes to me and they say, hey Scott, you know, we need to we've reset our server, or we've reset our thing, but we don't have enough memory to start. Like the system doesn't have any free memory in it. Like look how little memory is free, and then we just freed up all that memory that was over in the cache, and then they can restart their Oracle, and then everything will run happy. So this is kind of a thing that we do. This is one of the last things I'll do in a system before it may have to get kicked over. If somebody's just hammered up the system, right? Like they've really given the system the business, right? So, you know, free memory, can you clear free memory, or can you free all of the cached memory? And the answer is yes, I can wipe the buffer here. And you can go read up, there's blog posts on what the different 1 and 2 do. There's another command you can do. You can man sync if you want. Sync is also a thing that will synchronize cache writes to persistent storage. So you can do that against your system. So we used to do like a sync. Why we do it 3 is just old lore, and then we would, so everything that needs to would be written down, and then we would clear the caches out, right? And then the system would be pretty free. And who knows how much of that is actually, you only need 1. Yeah, fair enough. It's like my reboots. Everybody always asks me, why do you do 3 reboots? And I'm like, it's an old Linux thing, I don't know. Sync is blocking? Yeah. Okay. Fair enough. Oh, Magic sysrq is required. Okay. That's pretty good. Alright, so we can free all the cache memory. We can kind of see what's going on in the system. And that's the ones I can think of right now for memory. How about this one? So can you free the cache of all memory? Can you see how much swap you have? And free. How about we go back to this one? Can we tell how much RAM has been used? Let's see if this system has sysstat on it. I'm pretty sure it does. Can we do VMstat? And can we do VMstat maybe with a 1 and let's say with just a 1 on it? And if I just run that, and then I ask you, you know, as systems engineers, systems whatever we are, do we know what we're seeing here with this VMstat, right? And why might I have done a VMstat 1 versus like a VMstat 1.5? Do we know what these other values over here mean, right? Why are we doing these other values over here? It does not help with hardware. Yep. So VMstat with a 1, just one argument given at the command line, is going to give you output every 1 second in perpetuity forever until you hit Control-C like I did. VMstat 1.5, and this is a very common for all the sysstat, this comes from sysstat packages typically. Your very first argument that's given is the step or the iteration time. So this is 1 second, so every 1 second. And then over here is the number of iterations that are going to occur. So this is every 1 second for 5 seconds. So if I said, hey, could you guys do this VMstat right here? Can you do this VMstat for me on a Linux box? And could you do it every 5 seconds for 60 seconds? I want you to think about that before I give you the answer. Just because some people are going to want to do it real quick, so I'm going to let them do it. But for people that just want to see the answer, could you give me every 5 seconds for 60 seconds? It looks like this. Right? Every 5 seconds for 60 seconds is 5 iteration. It's 12 iterations of 5, right? And this is how we may gather information. Now you might say, Scott, what are you looking at here? There's a lot of stuff going on in this VMstat command right here, right? There's a lot of things that can tell us how used the system is and all those kind of things. And I actually broke these down a couple weeks ago on stream. And I have a talk. This talk is up in our Discord. And the talk is around Linux system administration. And in this talk, oh, this talk was open. In this talk, I walk you guys through VMstat and what these different numbers mean, right? And where, like, R is this number of processors, the number of processes that are saturating the processor right now. And is that a problem or not? And this right here says the number of processes running on the CPU, a value greater than the CPU count, is called saturation, because now you're waiting in any one of these slices. This is a slice every 5 seconds at that exact moment to see how used the system is. This system is very much not being used right now, right? We could put some load on it to see more, but we should see that. And this, I'm pretty sure this is up. I take it back. I don't think this one's up on the Discord yet. But this has a lot of information. I need to finish this one so I can put it up on the Discord. Talks about troubleshooting and baselining methodologies and troubleshooting, and man, there's a lot of stuff on there. Okay, I think that one's up on Discord if any of you guys need it, but I'm not positive. If it's not, feel free to just let me know and I'll put it up there. All right, so we said, can we tell how much of the RAM is used? And then can we tell how much RAM is free? Can we tell how much swap we have? This one's important right here. This VMstat with the swap in and swap out. I can tell you in modern Linux operating systems. This is very important. Like perk up if you say, hey Scott, I want to do this as an engineer and I want to like professionally do this stuff. Your ears should perk up at this. You do not want to be swapping on modern Linux systems. Now, who does want to swap? The modern Linux operating system. Linux wants to swap, guys. Linux wants to write memory to disk. Your disk is on average 1,000th the speed of your RAM, and your RAM is already about 100th the speed of the buffered memory that's next to the CPU. So you do not want stuff going to swap ever. Yeah, they actually make you turn it off. Yeah, K8 makes you turn it off. Because if you're swapping, I mean, just, it's bad. It's real bad, guys. We don't want it. So we turn it off. In older systems, and we still do this sometimes, although this is more rare. If an older Linux operating system, I know up to RHEL 5, you had to have swap. You still do have to, for the most part, have swap in most Linux systems. We used to just build a RAM disk and then point it to that. Yeah, we turn off swap. I've never used ZRAM or ZSwap, MoonPy, but if ZRAM is what I think it is, which is what we used to do, we would just build a RAM disk and then just point your swap at the RAM disk. So now, if you are going to swap, if you insist to me as a system that you are going to swap, which they do, then we just point it at a disk and don't tell you any different. So now you're, when I say disk, I'm sorry, a RAM disk. And the RAM disk is just part of our memory. So, oh, you need 16 gigs? Okay, you could just take 16 gigs out of the 2 terabytes I have. And I have to give up a little bit of my RAM, but I don't give up any swapping disk. That's probably what ZRAM and ZSwap are, right? I've never heard those terms, but I bet that's what that is. But we used to do it manually. I don't know if there's a tool that does it. I don't know what that is. Yeah. That's exactly what we used to do. Yeah. Interesting. I've never worked on this, and it sounds like it's an Arch thing, so I haven't played with it. CRM creates block devices in memory and compresses them. I don't know. Let's see. Interesting. Z-swap is there. Yeah, we used to just make a RAM disk and then just use that. I haven't done that in a long time though, and I've definitely never played with it on the Ubuntu side. Yeah, that's nice. Yeah, I haven't played with that. I'm gonna have to look that one up and play with that a little bit. I've never messed with it down in the Ubuntu systems. I just know what we kind of used to do in the Red Hat and Unix style world that I kind of came from. Oops. Is it dash A? Yeah, it's dash A. Huh. I don't see any in there. Swappiness. Swappiness is a little different. Interesting. Maybe I can't configure them down there. Well, sometimes you can set them even if they haven't been set yet. There's just a system default. Maybe I just can't see them on here. Yeah. So that's okay. Okay, so we can tell how much swap we have. That's good. That's important. By the way, guys, there's a lot of good stuff being mentioned in the chat around this that even I haven't heard of. But there's good stuff in here to like know if you're going to be getting into this. So you want to spend some time with this. All right. Then we talked about how you free all of the cache memory. And let's see. Do I have any other ones? Let's see if there's any other good questions that I can kind of glean out of this. Wait, that's my troubleshooting talk. We don't need that anymore. 1 second here. Hold on. Let's pull up this one, and I want to think if I have any other memory type questions I want to ask right off. Those are good for other stuff, but let's go look at memory, VMstat, dmessage for failure, star. Yeah, those are all good. I didn't think about IOStat for that. That would have been good too. VStat would be good. VMstat. We looked at VMstat, right? We talked about that a little bit. Let's leave that off to the side then. Okay. Let's go to let's talk about a little bit of networking. So with networking topics, go down to our networking topics, and let's say, can you show all the interfaces on your system? So can you show all the interfaces on your system? This is a good thing to understand. And then after that, we're going to say, can you determine your default route? And then we're going to say, can you determine your default route? And then we'll say, can you properly identify all of your IP or IPv6 networks? So can you identify all of these things? These are all important things to be able to do as an engineer, right? You say, hey, I want to be an engineer. I want to build these systems. Can I do these things? Hold on, let me make that a little bigger. All right, now maybe we can make it bigger this way. Big question for you. All right. Sorry, I'm playing around too much. So, networking topics. Can you show me all the interfaces on your system? You're just on some random system. You're sitting here playing. Can you show me all the interfaces on the system? Hold on. Skull Crusher said, what would be the point of swapping at your RAM? Wouldn't you be reducing the upper limit of how much RAM you have? Yeah, you would be, but you'd be telling your system when you think you have to write to disk, just write to this place, and then it would write to RAM, and it would be just as fast, as opposed to ever going to there. It's to fool the system into never using the hard drive, Skull Crusher. That's you answered the question, yeah. You trade CPU for, because that's to do the compression. That's true. Anytime you do compression, it's going to be down in the CPU. Desktop systems, it improves responsiveness and performance. Yep. Okay. Looks like we're on some kind of ad break, so I'm going to give you guys a second here. We will hang out here and watch Ranger Cam. And, oh, by the way, I'll tell you guys during the ad break, well, I guess people that are already here. We've got a Discord. You guys can hang out in Discord. There's also a bunch of labs. You guys can go in the labs if you want to. And I'm specifically in one of the Killer Coda labs here, just hanging out doing stuff, right? Hanging out working on stuff. So the question here is, can you show all the interfaces, all the networking interfaces on your system? Can you do that? Right? Can you do that? I'm going to ask another one here. I'm going to add one in here while we're on break still. Can you show that the interface is connected physically? All right. So, IP-A, that's one of the ones I would definitely use. IP-A or IP-Adder, that's a great one. They're the same command. So can you see the actual network that's there? This is probably my most common one. You can also do ifconfig, but ifconfig is not on all Ubuntu systems anymore, apparently. There's another one, MoonPie. Yeah, I use IP-A or IP-Adder because it gives me enough information. So I think that that's a great one. I think it's shorter than ifconfig for me, and I think it does kind of what we need, right, for the most part. Yeah, ifconfig was kind of my way to do it, and ifconfig was also really great because if any of you are on the Windows side of things as well, maybe you do some Windows in your world too. Right, because as systems administrators and engineers, sometimes we've got to touch the Windows boxes, even if we don't want to. They have IP config, right? So ifconfig and IP config were super convenient because they were just back and forth between the two of them, right? Yeah, Tawny, that's true. Containers can't have their own interfaces as well. But can we show all the interfaces on whatever system we're on? And I think that that's okay. So you need to be able to enum through all network namespaces too. Okay. That's probably fair. Thanks for the follow. Did I miss any from earlier? No. Interwebs Creative. Hopefully this stuff's useful to you. We are doing Linux. So any of you guys that have been around, you know that pretty much all we do on here is mess around on Linux and watch my dog Ranger down there act like he's the saddest dog on planet Earth. But I assure you guys, Ranger is probably one of the most comfortable old animals on planet Earth. He is super comfortable, and he lives at a balmy 73 degrees Fahrenheit down there, where his only problem is how much he's going to shed for the day. So that's Ranger down there for you. Binary 64. Hopefully this stuff's useful to you. Thank you for the follow. Follows are free guys. Free guys. So if you find this stuff interesting, feel free to. Look at Ranger. He's like looking around like, oh, something's happening. Maybe my wife just came home. I don't know. Yeah. Yeah, Binary. If you want to, oh, come on, Ranger. Not on the camera, Ranger. All right. Anyways, so what interfaces do we have? So looking at this as engineers and administrators, we've got a loopback interface. Now, if we just want to talk networking for a second, all IPv4 networks, if you're using IPv4, IP version 4, you are going to have a loopback interface. And that loopback interface is always going to be addressed to home. 127.0.0.1 is always home, right? Right? That's just how that works. Now, that is your home IPv4 address. That's how you ping home. That's how you test the network interface for connectivity and that it's working. And then over here for INET 6, so that's INET, and the assumption there, well, actually it's just INET 4 is INET. INET 6 is IPv6, right? So it's a 128-bit address. But when we want to talk about the scope for host, it's : 128. So that's how we represent our home in IPv6. So I can see the new shirts now. This was the old nerds on college campuses used to wear this, and now it's going to have to look like this in the future, right? Came here because I was checking out NixOS. Yeah, Binary. NixOS, people have mentioned that before. Is that one of those ones that it's... somebody had mentioned before, I think it's an immutable OS, isn't it? Like you can't change it? If it's the one I'm thinking of. I'm not 100% sure, though. So, okay, all right. So where are we at? Then we come down here and we've got this ENP1S0. And this one has only an IPv4 address on it. This one doesn't have an IPv6 address on it for some reason. This is not what we would call a dual-honed internet. So it's not running an IPv6 as well. And this one has a 172.30.1.2/24. So when you see a /24, and I've got a network primer that delves into all this, but we know that 172.30.1 is the network portion, and the last 8 bits, which are represented by this octet in what we call dotted decimal notation, is the host portion. So in a /24, 172.30.1 will never change. Everything that we're doing is over here between 0 and 255. 0, so 172.30.1.0 is the network address. 172.30.1.255 is the broadcast. It's the last one in all these numbers, in 0 to 255. So 1 to 254 are all the usable hosts in this network. It is 2 to the power of 8 minus 2 of total hosts. So 1 to 254 are all the usable hosts in here, right? We happen to be number 2. So we're the second one. The first one's typically the router, but sometimes people move that around. So this is a high candidate right now for being our network interface, right? We're talking about, can we see what's going on there? And then we come down here for Docker 0. Docker 0 is a 172.17.0.1/16. So when we have a /16, that means there are 16 network bits, which is 172.17. It means that the .0.0 is the network, and the .255.255 is the broadcast. So the total number of usable hosts in here is it's 2 to the 16th power, which is 65,534 usable. The 00 is thrown out because it's a network, and the 255 is thrown out because it's the broadcast. All other ones in between there are just usable hosts on the network, right? So this is just the Docker internal address that we use for, whatever. So yeah, I can probably surmise that this is going to be my actual interface that I use, but I didn't ask you for that. I just asked you if you could show all interfaces, and I think IP-Adder probably did it. But I wanted to show you guys some of the things that we might be looking for in here as engineers, okay? You also have your MAC address. Your MAC address is 48 bits long. They are expressed in hexadecimal. So this is 4 bits. This is 4 bits right here. This is 4 bits. This is 4 bits. That's 4 bits. That's 4 bits. So that's an octet there itself. So that's 8 bits. That's 8 bits. That's 8 bits, right? So it's 48 bits total. The first 24 bits is going to be your vendor portion. F205, F6 is going to always be some same vendor, and then the individual product portion is the last 24 bits, if you guys didn't know that. Okay. Have you tried TLDR? It is very helpful and useful. I have not tried TLDR, Flat Earth Dave. I have not used that at all. Okay, so what's our next question here? Can you show the interface is connected physically? So this is a problem. We're on a virtual machine, but is there a way to tell that this device has a link active? That's actually maybe a hint here. Is there any way to tell that this is link active, right? So if we're on a virtual machine, there is still a virtual switch that this interface connects to. And this actually is existing as though it's a real NIC. So how can we test that, right? If I were on one of these machines here, connect to my virtual machine. There's a reason this wasn't connected. Kind of a long story, but let's say I connect into this, and I'm connected to each of these. Any one of these machines has networking interfaces that are connected back to a network virtual switch or network that's inside of here, right? So we're over here. How can we tell if one of these interfaces is actually properly connected, even though we're in a virtual machine? You might say, Scott, you're in a virtual machine. You can't go just back looking there like you used to and making sure that it's yellow or green. What are we looking for here? All right, make sure I don't miss anything. Mesh Central, thanks for checking. Okay, so let's go here. Let's say that, and it might come as a surprise to you, but even though we're on a virtual machine, ETH tool is still the way that I could do this. So if I wasn't physically near my virtual interface, or I wasn't physically near a server in my data center, this was actually a really excellent way to see, is my link detecting yes. This is an old trick. You know, when I used to have to get up and go walk over to my data center, and actually at Lockheed Martin I had 4 different data centers that I would sometimes have to go into during the day. And if I was connected to a system and there was some type of problem, maybe I had multiple interfaces and I was trying to bond them and make sure that one was up. If I just suspected that, or I didn't know for some reason why the interface wasn't working properly, I could come in here and at least see if I see link detected yes, I at least know there's a cable plugged in, and I at least know it's going to some switch somewhere. Because link detected will always be no if your system doesn't detect the link on the other end of the connection. So this is really important, right? As a systems engineer, you know, how often I have to get up and walk around is maybe something I don't want to do, right? Maybe I just want to hang out at my desk all day. I don't know. It's probably good for most systems engineers to get up and walk around, but we won't get into that part of it. But you can check your link to see if it's detected on anything, really. But it's very, very useful. So can you show that the interface is connected physically? And the answer, show all the interface on your system. Can you show that the interface is connected physically? And the answer, that should be yes. Okay. Can you determine your default route? So we clear the system up. We did an IPA. Seen those videos called the websites? Oh, we used to, one of my favorite videos back in the day was the old Strongbad, which was actually Homestar Runner. And if you ever see Homestar Runner make a techno song, the song in the background, the gratuitous old movie quote is, "The system is down." The system. Binary, I don't think you can link here, but you can link in our Discord if you want. And then we can pull it up. But let's look at IPR. IPR is the routing table that our system has built to be able to send data out to places that it knows. So if you are sending anything to 172.17.00/16, it's going out the Docker interface. Well, that makes sense because that's the network for the Docker. I told you guys that earlier. That is the network for Docker. And if you're sending to anything 172.30.1, you're sending it local in here off of the ENP1S0. But if your system doesn't know where to send something, it needs what's known as a default route. In routing, this is called the gateway of last resort, or the default gateway, but in systems world it's just called the default, right? And the default route here is going to go to 172.30.1.1, and it's going to go out of our device ENP1S0. So I should be able to ping 172.30.1.1 and get pings back. All right. So the next one might be, they said a default route. Okay, slide. Can you ping the default gateway? Can you ping the default gateway 3 times? Of course we can just ping it, but can we do it just 3 times? Yeah, -C3 will ping it exactly 3 times. Clear my screen up. Ping it exactly 3 times. And what's the default? Maybe what's the default time between pings? Every 1 second, right? Keeps a sequence for us. It tells us how long the round trip was. That's useful, right? What's the round trip time? I'm about to lose this environment, and then we'll start it over again. But okay, we got that. Can you properly identify all of your IPv4 and IPv6 networks? I think we did that. IPA showed us all of the pieces that we needed in here, and I think we broke them all down, so I think that's good. Okay. And then I'm going to exit this, and I'm going to Let me know if I'm back, guys. Jeez. Black screen ad. You know, guys, it happens every time ads runs, which is kind of weird. Although it did block out to. Jeez. Am I back? Can you guys hear me? Man, I apologize, guys. That's this is strange. Now, I will tell you, I do think my Cox internet's still jacked up, but we can check that real quick. Let's see if Cox has been having. I was running on my home or my alternate internet all day. I was doing all my engineering today on my alternate internet. Cox is definitely still having problems. Let's go look at instead of the last 90 days, let's look at the last 7 days. Yeah, look, this started the other day, right on Saturday before I got home from Vegas, and look at the outages that I've been getting on Cox. I'm just staying away from Cox this whole time. But I mean, I haven't had a Cox outage today, so that problem seems to me. Let's see, 1520. That was a few hours ago. That problem that happened there seemed like it was a Twitch thing again. But I don't know, because it did look like my internet went down. My streaming on YouTube looked like it went down as well. So that kind of sucks. All right, maybe it reconnected. Oh, it looks like it's back connected again. So. Alright, I should be back, guys. I jumped to my other internet. I got tired of that other internet. You guys back? Let me know when you guys get back, please. Sorry. It's I jumped to my other internet, man. Yeah, I wish there was a way to have a Cox service level agreement, but for sure they're never going to give you one of those. Because they know they have shitty service, so they're just going to keep doing what they do. All right, I'm back. I'm on my other internet, guys. I'm on my CenturyLink that, while slower, does at least not go down. The only bad thing is none of this stuff works over here anymore. So none of that stuff works. There's no reason to hang out and watch Ranger Cam, because it literally doesn't work when I'm on the other internet. All right, we're back. Okay, yeah, we're not going down again, guys. That was I'm off that internet. I'm on the other one. That is just some shitty ass. Man, you guys make me curse like I'm back being in the infantry again, right? Like they want to piss me off. But they're a terrible service, and they don't care. There's a really good South Park episode on how the internet companies, which are mostly cable companies, think about it. And if you ever hear them going and complaining to the people, and they're just like sitting there like loving the complaints from the kids, that's exactly what it's like. But all right, anyways. Oh god, that's annoying. All right, so let's see if we can do this. Can we list our open ports? Do we know how to get all the ports out of a system? All the open ports in a Linux system. What might we do that? Who knows? Right? So we're just going through anybody that got here late. We're talking about kind of the Socratic method of learning, and I'm asking you questions, and we're having a little back and forth about how the system works and what we can do. And we got all the way down here to, can we list our open ports? What are our open ports? Inspector, yeah, the salty catfish. That is, we're not sudoing anything. We're already root, so we just do our rm-rf by itself. That's how we do it. All right, but don't do that command if you're, don't do that command. But Salty's here, so that's good. We're walking through, and can we list our open ports? How do we do that? Nmap-A, maybe. Nmap's not on our system. What might we do? We can do netstat, but netstat's also not on our system. So what do? Well, the newest way, no, Salty, I've been dropped twice. I've been dropped twice, and I jumped over to my other internet. So, yeah. Yeah, disconnected from chat, yeah. So let's do this. I won't disconnect anymore because I'm on a more stable internet now. So we'll do an SS command, and SS is going to give us a bunch of information about our system, a bunch of information about what's established, and I just necessarily, all I want to see with my SS command is ss-ntulp. And this is going to show me my TCP and UDP connections of the system. What's being listened to, what's being exposed out to the world, and what's being listened on. Moon pie dumplings, that's a good question. And that's an accurate question. And actually, that came up the other day. I am the root user on this system. But the reason, this is something they do in this lab. I don't know why they do it. But if anybody ever wants to change that variable, it is the PS1 variable. So we could set the PS1 variable equal to backtick H and a £sign if it made people feel better. But it doesn't affect the system in any way. So that's the PS1 variable for any of you guys that are, learning Linux and figuring out how to do things. Typically, we do use the £sign or the octothorpe, as it were, to denote that we are the root user. But we can do ID, not OD, ID. We can do who am I, and these are ways to see what our user is. But I am definitely the root user. But it's just that's a good little catch for people that hadn't noticed. But we set the PS1 variable to set that, and there's a bunch of things you can do with the PS1 variable if you want. Specifically, sometimes the path or the host name or whatever. There's a bunch of different things you can do. All right, so in here we see UDP is unconnected, and here's all of our UDP systems that are being listened to up here. And then we've got all our TCP down here. TCP is listening down here, right? And I said, can we list our open ports? And yes, we can. Now, I'm going to back up again. And again, we're kind of building this as we go. So can we list our open ports? Yes. Can we? Let's see. This one would be a little more of a challenge for some of my senior engineers. What file do we edit to change the service to port number mapping? So, what do I mean by this question? What file do we edit to change the service to port number mapping? So right here, I said ntulp for, and then down here I have these ports, right? But over here, as we're listening, the system identified which ports it was listening to, and we can actually change those. Those are being referenced somewhere in the system here. Well, what if I told you guys, go ahead and grep SSH from Etsy services. And SSH is mapped to 22 on my system. Hey, Fisherman, how's it going? So if I do a netstat -ntul and I don't put the P on there, right? What did that take off? Sorry. I need to put the P back on and take the N off. N is numeric. You'll see here that it's going to try to identify the port for me. It's going to try to be nice to me a little bit and give me what it thinks the mapping is here. But I'm going to tell you that mapping is coming from Etsy SSH services, and then I'm going to prove it to you. You say, Scott, how are you going to prove it to me? How am I going to prove it to you? Well, I'm going to do it like this. I'm going to go to VI Etsy services. I'm going to go / to SSH and hit enter. And I'm going to change this from SSH to stream example. Do we all agree that stream example was not in this file before I just did that? Well, we don't. I guess I didn't prove that to you, but I'm going to do this. And now, look at that SSH mapping is now mapped to stream example, even though it's still just port 22, right? Fisherman, you were having Python environment woes? Yeah, that can be a hassle. The guy to go to for that is definitely Salty Catfish. He's definitely somebody that can help you out with that. By the way, guys, we're also dual streaming over on YouTube, and I did have to jump off of my Cox Internet because Cox Internet dropped us twice back to back. So now I'm jumped over here in. Now I've jumped back over here on. I'm on my Cox. My CenturyLink. So if I VI this and I come back here. By the way, I just did a very bad thing in the systems world. Typically, we won't edit a file unless we've made a backup copy, but I know that this is a lab environment, so I don't care anymore. But this is SSH. That's what we knew it was. That was the protocol. So then I come back here and I look again, and now with the mapping that it does, it gives us this. Now, if you throw that N on there, again, like I was doing, and by the way, the N can go anywhere. These are just options that are given at the command line. And then now it's not gonna bother mapping that for us. And I'm gonna tell you, as a systems engineer, you're probably gonna, over time, move towards just looking at them like this. It may be nice as you're learning, maybe, to take off the network force, the numerical forced value. But I'm just going to tell you that domain right here, to me, is less useful as a value than 53, because I know for damn sure that 53 is DNS, right? I thought I knew what it was until I started talking, and then I didn't. It's DNS, right? Always DNS. But its system resolve is what's the process running it. Okay, so that's how we get the stuff out of there. All right, give me 1 second. I need to go grab some water here. Now, I thought the wife was coming home for a second, but I haven't heard her yet. There's a shout out for fishermen. If you guys don't follow fishermen, you should. Follows are free. Salty as well. You guys should follow both of them. They're both on here streaming every now and then. And okay, so I said, what file do we edit to change the service to number or port number mapping? And the answer to that was etc SSH. Now, does anybody know what port number 666 maps to? Does anybody know what port number 666, without Googling it? Obviously, you can Google it. Google's easy. But does anybody remember? Was anybody around? Nope. You're close, Salty. You're close. It's a game. It's a game. The devil. 66 isn't mapped in Etsy services, but it used to be called the Doom port. It was for the game Doom. Doom was the one that used 666. You remember the one that came after Wolfenstein 3D? And I think they actually just remade Doom recently. Yeah, it was Doom. Yeah, in fact, just so you guys see I'm not lying to you. The Doom port was 666, and you can go find it. It's been reserved since Windows 95. And if you go look up, so if you go to Wikipedia, well-known ports, which are 0 to 1023, right? That's our first 1024 ports are well-known ports. And you go slide on down to 666, it's still there. Well, it was the other day when I checked, and I showed this to my college students, so I know it's normally there. Doom. Boom. In case you didn't know. And then the unofficial one down here is AirServe NG and AirCrack NG server for remote controlling wireless devices. But the official one that was registered was Doom, in case you guys didn't know. So then, boom, there you go. Now you guys have something you didn't know before. But you also probably, unless you were a network engineer, you probably may have not known that 0 to 1024 are called the 0 to 1023 are your well-known ports, right? And then everything after it are reserved, right? So well-known ports are 0 to 1023, and then you've got your reserved after it, and then I want to say after like 40,000 something are just your upper ports. But we call those the well-known ports. It's good to know, all right? Yeah, Salty, those are the ones that most people know. And 3389 as well. 3389 is going to be RDP, and it's going to be one of the most commonly exploited ones. 22 and 3389 are connectivity ports, and you almost always turn them off in the cloud, right? Or at least have an alert for it. Also, Salty, I don't know if you saw it come through today, but I'm going to be giving a talk on getting into the cloud space. So it's going to be more about migrating workloads out there, and I'm going to be leaning heavily on some of my 3389s just for jerks. Yeah, Salty, it's going to be good. I think it's going to be good, but I think all my talks are good, even though they get met with mixed reviews. So there we go. All right, Johnny, man, that talk is going to be done in my company Redline, the company that I work for, and then I am contracted out to other companies through. But I will, as I always do, Johnny, man, I will make a a pre-redline version, because I like to test on you guys. You guys are like my little test space, right? I use you guys to help me build out my different stuff, and you will definitely see it on here, Johnny Man. You will just see a version that is pre-redline before I brand it over to the redline side of things. So you'll see it. I mean, you guys have seen all my other talks, so if you don't mind being my scapegoats, right? Like, you're the ones that I basically just hammer on and show you guys how this stuff works. All right, so that was that. Let's talk about some disk topics then. Whoops. Disk topics are our next one. And our first question will be, how do you check how many disks you have? All right, so that'll be our first question. And then we'll duplicate the slide and we'll say, how do you check how many disk partitions you have? So that'll be our next question, right? And then, how do you check what file systems are on the disks, on the partitions? Okay. How do you check what file systems are on there? And then I'll say even harder, how do you check, can you check that aren't even mounted for file system? Can you check file systems or partitions that aren't even mounted for those file system types? Okay, don't worry guys, we'll go through these questions in a second. Okay, and then let's look at duplicate slide and say, what can you check? Oh. Can you check disk I/O? Or we'll just say over time. Can you check disk I/O over time? And then let's add another one. Can you verify disk read and write speed? That's a good number for now. We'll add more, guys. We'll keep adding more to this as we go. But let's do some disk topics, all right? So this is the stuff that I want this group to be about. Like our Linux engineering group is about getting you into doing this professionally, understanding the basics, guys. I'm a big fan of understanding the basics. I think if you know the basics of things, other things will work well for you from there, okay? Hey, Robodom, I hate to ask you to be a test subject, but will you go make sure that the live YouTube stuff is still working? I don't know if you mind checking that for me, but just see if it's over there. And we do have, I think, a YT. This might work, but if anybody wants to watch over there as well. I don't know how persistent those are. I don't know if those stay. I did load up 2 talks over on YouTube for you engineers that are like, hey, I want to see some networking primer, or I want to see our high performance compute talks. I did load those up yesterday and the day before, I think. So you guys are welcome to go hang out in there and get those. All right, that's all up to you. But let's do some disk topics, okay? Disk topics and go through this. Twitch is superior streaming. Yeah, Johnny man, I'm not saying it's not. It's just, and I'm much more well known over here. But I want to have the YouTube for persistence, if possible, and I also want to have the YouTube for just there is more reach over there. There's more people that know. I mean, your 80-year-old grandparent knows what YouTube is, but not a lot of people know what Twitch is. I have guys my age in tech. I have guys 10 years younger than me in tech. I'm 42. I have guys in their 30s in tech that have never heard of Twitch, and they're in tech. Twitch is not, like, I would call Twitch not even 1/100th the size of YouTube as far as like knowledge. When I say that, I mean like of people in around the world knowing about it. So yeah, Robodom, I appreciate you. You're the best. Yeah, Salty, I'm trying to make this stuff good for you guys and get you guys all down there and talk and shop with other engineers and stuff. So okay, so how do we check how many disks we have? Some of you guys have probably figured this out or thought about this before, but one of our commands is we should have fdisk on the system, and fdisk-l will dump a bunch of information to our screen. That's almost too much information. Now, Salty, df-h is great, but df-h is going to show us mounted devices, which is slightly different. It's going to show us what's mounted, but all the disks in our system may not be mounted. So there are disks, like there are disks that are basically they're just like hidden under the hood. We don't know, they may not be mounted. DF-H will show us what's mounted, and that's great. But I want to go even deeper. I want to start way back at the what's there. And by the way, fdisk will show us devices that are not disks. These are RAM disks that were built. These dev loops, they're not real devices. So we have one disk right here, dev VDA, and then we have 3 partitions of this device, VDA1, VDA14, and VDA15. They do not have to go in order. All right. Cipher Enigma, there is. Yeah, sometimes you boot a, yeah, so here's one that I used to use with Solaris. We would have in a Solaris device, in an older Solaris hardware, because Sun used to make their own hardware back in the day. We would have 2 disks. Fdisk is normally there, Salty. Yeah, Fdisk is normally there, and so is parted. But I don't know parted well, guys. So I don't really, quit. I don't know parted very well, but you should be able to do like parted, but dev VDA maybe. And then you can pick the device that you're going to go and partition. But I don't know that very well. So I typically just do an fdisk-L, and that'll give me a lot of information. But typically, I maybe know that it's a VD for this system, so I'll grep-I for VD, and it'll give me just the disks that I want to see. In my home lab that you guys sometimes see, I have this XVDA, and I'll check for XVD, and then you'll see all the disks that I've added to my servers. If you want to see an example of that, I can't connect to those because I'm on the other internet. Damn it. Just always getting messed up by the damn internet problem. All right. But Cypher, yeah, you said, would we ever do it? So in those systems, we would typically have an SDA and a SDB device. So that's the first disk is the A, and the second disk is the B. So dev VDA and dev VDB in that example, let's say. And then what would happen is you would only ever mount the first one, and the other one you would just DD the disk duplicator command to copy your primary disk over to the secondary disk. And if the primary disk ever failed, you would always be able to boot to the other disk. That was our way of doing things. So, by the way, anybody that wants to do these labs, the labs that I'm working on, I'm actually just asking you questions, and we're going through things here. We're just doing this, which is the learning Linux through the Socratic method. I'm asking you guys questions. You guys are giving me back feedback, and I definitely appreciate. We have a few senior engineers in here that have been helping out quite a bit with just different commands and things that are useful. But I'm just asking you a bunch of questions, and we're down here in the disk space, disk topics, and we're doing how many disks might you have. And on this system, we have one disk that has been carved into 3 different partitions, right? So that's the answer to that. And then the next question is, can you check how many disk partitions you have? Well, it's the same thing. It's right there in that. But we also have a couple of other commands that are kind of useful. So fdisk is good, but we can also lsblock. lsblock will list all the block devices that are known on the system. And here we go. This even gives us a better answer. There's our disk, our one disk, and there's the 3 partitions of that one disk. So lsblock is one of my favorites, right? And then I have a question down here said, how do you check what file systems are on the partition? So how can I see what file systems are on here? Now I can see where they're mounted, and I could probably go and do the mount command. What is a loop device? A loop device is a RAM disk. It's a disk. It's a device that's made inside of RAM that the system mounts and does whatever it needs to on. Yep. lsblock-f. That's going to give us, that's a really good one. Flat Earth Dave, I like that a lot. That's going to give us some really good information about the file systems that are there. By the way, that's the next question. Can you do it for file systems that aren't mounted? And the answer is yes, you can. lsblock will do it. And block ID is also a great way to kind of see what's going on inside of these systems. Specifically, we can see the labeled type of ext4. And ext4, that's a type of file system, right? So lsblock-f gives you good information. Block ID gives you good information. And then what is another one here? that maybe you want to look at check partitions that aren't even mounted. What if you wanted to check mounted partitions? So you can always type mount, but I'm going to tell you guys, mount is probably going to throw so many things on the screen. It's going to be 39 lines. So mount is going to be a lot. Let me just tell you, mount is going to be a lot. But we can at least look at the mount command to try to find things about what's going on in our system. So I may do a little bit of grepping here. Let's say that I wanted to get rid of some stuff that I thought was a little bit noisy here. So let's see how we can grep for our own benefit. I'm going to grep -V to invert the search and remove C group. I don't care about none of that C group for right now. Okay? Gotta get rid of it all. And then if I clear the screen, I only have these things, and I'm gonna say, well, maybe some of the sys stuff is a little bit too much. That's a little bit too much noise for me. So maybe I grep -V for sys, right? I don't want none of that stuff. And I'm getting a little less, right? And then I say, well, what else up here might be a little annoying? Maybe things I don't need to look at. Oh, that's fine. That's fine for now. That's good enough for now. And right here I see my dev VDA1 is on /. That's my root file system. And it's ext4. So my file system of this server, if somebody were to ask me, is ext4. Now I can go look at that information. I can look up ext4 and see, you know, somebody might say, hey, is that a journaled file system? And you go, I don't know, I never even heard of a journaled file system. And then now you go look it up, right? Journaled file, it is a journaled file system. Everything after ext3 and after are all journaled file systems. ext2 and before are not. XFS is journaled, ButterFS is journaled, all of these things, right? And journaling is good. We need journaling so that file systems work properly nowadays, and it's been a way like that for a while. Okay, so where are we at here? We're so can we see the partition? So look, real quick before we get too far, and I want to show you guys that there are always the history commands. So any of these commands you're doing, they may be coming at you fast. There is the opportunity to just drop those commands back in later. Grab your history, throw it out in a notepad. This was a notepad. This was a API key the other day when I was doing on stream the API key for my InfluxDB. That's a long gone InfluxDB, but I can grab all of this stuff in case I'm going to have a hard time remembering it and throw it over here in my notepad and clean it up later, right? Let's go for volume before we go for paring it down to the exact commands that we need, right? But we can gather all of this stuff. So don't be afraid, don't be afraid to grab stuff and copy it, right? It's your system. And do you guys, I mean, look, we're not all computer science majors, but do you know how many of these, do you know how much of this I'd have to save to even like start to tax my system here? I have like 1.5 terabytes of space in my home environment here. Like, that's not even probably like, I don't even think that's 100 kilobytes right there. I can do this all day, and it's not going to add anything to my system. So my point is, save this stuff that's cheap and free, and try to, you can even be copying these commands down if you want. I meant to tell you guys earlier, like, get out your damn notepads, right? Like, if you want to learn this stuff, you're going to learn it. 1.5, terabytes? Yeah. I have many terabytes on my home system here, yeah. I don't even know how many. I guess I could look it up, but I mean, that's not even that much. I mean, that's how much free I have RoboDom. That's not how much I have on there. Oh, I could put a lot of Steam games. Actually, I found a really good Steam game today. I found a really good Steam game. I was watching what are they called? Pirate Software, and they raided us over to this guy who had like 3 people, and he had like, Pirate Software had like 5,000 people, and he raided this dude that had like 5 people. It was hilarious. And but the game he was playing was really good. If I can find it, I'll show it to you guys. But it was a really fun game. It was a block breaker, but also very much like a Thor. It was Thor, and then it was. Let me see if I can find this block breaker. Hold on. Shoot, I do not remember what his name was called. Was it Drag Me? No. Was it like escape? I don't remember what it was, guys. I'll think about it. Specifically pick the lonely tag. Well, it was a guy related. It was a guy related to his streaming, like a guy that's part of his stream team. But still, it was still funny. Okay, let's go to our next question. Can you check disk I/O over time? This one's a little harder. This one requires that you use specific tools, and the tool that we're going to use is IOStat. -D specifically. And IOStat's not found, so we're going to have to do an apt install -y sysstat. This is probably sysstat. This is probably one of those things that you should have installed on your systems, right? And this one's pretty good. All right, I gotta change the song. Hold on, guys. Every time the song comes up, I gotta change it. It comes up about this far into any of my streaming. All right, good. That's enough of that. All right. So we've got that command now, and let's run it. Let's run IOStat -D, and it's going to give us one output of the devices. Now, IOStat can also show you just the processor if you want, but I don't want to look at it like that. That's one slice. That's 1 second as it happened, and I want to maybe watch. Let's say I want to watch every 1 second for 10 seconds and see how my disk devices are doing. Now, here we got our kilobytes reads per second and our kilobytes writes per second. And then I have over here my disk cards. So disk cards are if I'm having some kind of errors. Did you know that if you start to see errors increasing over time in your system, and you can track all of this. We track all of this with Telegraph, right? We can start to see if there's more disk errors on a system, and we can predictably find if a disk is going to fail well before it ever fails. Did you know that? But who's going to be sitting here watching this? Not many of us. So what we have to do instead is we have to feed this out into a system to monitor it for us, right? That's what we do with monitoring, right? So yeah, so now I can watch disk and CPU if I want every second, but that's going to get a little noisy. But I can see how used my system is. My system is not under heavy load, but I can see where my system is under heavy load if it were. All right, so IOStat is an excellent tool for disk I/O over time. So, what if I told you guys that we could then test and we could start to really mess with our system? I'm going to set my IOStat to look at the disk, and I'm going to look at the disk of my system every 10 seconds, forever. Every 10 seconds on this tab, I'm going to look at my system, what the slice of reads and writes in at that time are, right? Now I'm going to come here to tab, right next to tab, and I'm going to press a button and I'm going to build a new tab over here. And now I'm going to start messing with the system, right? So I'm going to show you guys. It said, can you check the disk I over time? We could. Now I said, can we verify disk read and write speed? Yeah, let's see if we can do that. Let's go over to this other tab over here. So I'm going to leave this running over here so we can see how we're abusing the system. But over here, I'm going to do a DD command. DD is this simple little command that is going to be called the disk duplicator. Salty said a hardware question. Is my impression that idle should be minimized to represent your system is maximized? Yeah. So Salty, let me explain what you just said in a way that explains why we carve up systems into things. But this is a good question. That's a crux of the matter question. So I really like that you asked that like that. Let me show you guys something here real quick. Hold on. Let's go to my virtualization PowerPoint. So I'm gonna pull up virtualization, and I'm gonna pull it up over here, and I'm going to walk you guys through. Let's talk about virtualization real quick, and just real quick at a high level before we go on with the other stuff. Let's talk about why we virtualize and what it is, right? So this is a hardware question, but it's the crux of the matter. If we look at this was my machine back before I taught a college class a while back, and the machine I want to say about a year ago I took this, and I want you guys to think about this in a utilization. There's 100% utilization up here, and this is my CPU, and my CPU was down here being utilized at about 30%. but let's say the average is probably about 15. Would you guys say the average is about 15% over time? If that's 20, it's lower than 20 most of the time. So let's say it's about 15 average. Would you agree with that, Fisherman? Is that or wait, Salty? Yeah, the crux. You say this is the crux of the matter, Fisherman. Yeah, yeah. This is where it actually makes sense. So I want you to no object. You can do an exclamation mark for objection, unless you're saying no objection, which I don't think you are. But if we average 15% utilization of my CPU, and I was doing everything I wanted to, guys, I was playing around with my computer, I was playing video games, I was doing whatever, and I was using 15%. Does it make sense that in each of these seconds, I actually lost 85% of my CPU? I used 15%, but 85%, all of this up here was lost forever. It went to bit heaven, or it just wasn't used, or the passage of time, right? This thing, all things devours, birds, beasts, trees, flowers, right? The old Hobbit down in the cave with Gollum, right? That's that's time, right? 85% of my system was lost forever for each second, right? So what virtualization is us looking at a system and saying, look at all this time that's being used, but more importantly, look at all this time that's not being used up here. Bit heaven, I hope you accept me when the time comes. This game that I was looking at earlier, that I was playing, was literally about it was really funny. It was about a person that was polytheistic being thrown into a monotheistic hell and trying to escape. That's what the game was. It was actually really funny. But I can't remember the name of the game. I think I have it on Steam. Oh, I did download it on Steam. Hold on. Do you guys want to see my Steam? You guys are going to make fun of my Steam. Oh, that's what it's called. It's called Against Great Darkness. It's a little demo called Against Great Darkness. Yeah, it was, guys, you could play it online too. It's a really well done little game. But what it is when you play it, it's you playing a it's a brick breaker game. You're breaking bricks. You're just moving around and breaking bricks, but you're also shooting. I'll pull it up real quick. I'm not going to play it right now, but if it'll pop up for even a second here. It's on my other monitor. Oh, I don't think I can move it over there easily. Hold on. Windowed. Pull over here. I'll just show you guys real quick, and then we'll go back to serious stuff. If I play this game real quick, you just pick somebody like this. Pick whatever you want, and then you say, all right, this guy, and it's a block breaker, so you're going to move. You're down, you're a pagan, and now you're trying to escape your hell, or whatever. Now, you can just shoot things if you want, but you can also... Oh, damn it. It split on me. You can also hit the blocks, and they become more powerful. And if you hit them while you're moving, they become even more powerful. I'm not really trying to dodge anything. I'm just hitting stuff to show you guys, right? And you can speed, like, kind of speed hit them. Make them more powerful and stuff, right? And you keep procking new ones as you go, and that was some new ability that I haven't seen before. And you just beat things up like this, or you can keep doing, whatever. I don't know. All right, anyways. And then you can keep going and building your game up. But it's Against Great Darkness. It's a game that we got dropped into. But back to virtualization, Salty. You caught me monologuing, right? All right, so back to virtualization, what it is. It's this idea that this system here, look, this is one of my XCP NG machines. This is a physical device that has, this one here, it's a little bit older, but he's got 12 core. I think he's got 12 cores in him, and look how unused they all are. Look at all the space being lost forever. So what we could do is we could put more and more systems on there to stack up. If every system just wants to use 5%, we'll just stack more and more up until we start to get, we've got just the basic systems, and then we add more and we add more and we keep adding more. Yeah, there's so much space for activities. Yeah, that's exactly what it is. And we can keep being more and more dense. In fact, much more dense than modern virtualization is to go into containers. Because within this, when we get down to containerization, and this is my talk on it, when we get down to containerization, I'm barely using any of these systems here. I'm barely even using any of these, and I'm like very, very dense on my virtualization, going even further. I would show you guys on my home lab, but my home lab is all jacked up right now because I'm not on it. But anyways, join the Discord if you got more questions about that stuff. But hopefully that helps you out to answer that question. That's why we want more and more guests on each virtual or on each physical host, fisherman. Because when I started in the industry, we were typically just down there one machine per. So each machine was just sitting there, and if we weren't spinning it up like crazy, it was just sitting there idle and wasting CPUs, doing what we call turning electricity into heat. That's all it was. And it's all time division multiplexing. So it's all just waiting for a slot of time against the processor. That's what it all is. All right. So anyway, so yeah, and Salty, when I get back on my other system and I can show you, I can pull this up and go much more in depth about that for you, and how, since we don't have a physical device anymore, each of those virtual machines has to be given the CPU, the memory, and the network from the host, right? The host has to handle that, and the different ways that we do that. All right. By the way, guys, this is still spinning. Every 10 seconds, this is going. Let's go over here. Let's beat this poor system up. The question was, can you verify disk read and write speeds? And I say, I think I can give it the college try. I'm going to say DD, and the in file, where DD is going to copy from, is going to be dev0. Dev0 is a special block device that's part of the operating system that whenever something goes and checks, Liquid Venom, unfortunately I can't do a Ranger check right now because, here's why I can't do a Ranger check right now, because we are doing, we're on the other network and I can't check on Ranger Dog. Ranger is on a camera and he's over here. So this is what Ranger looked like when I jumped off. That's what Ranger did look like. So that's kind of a Ranger check. But that's I can't see any of this data right now because we're jumped onto the other network. So that's unfortunate. But all right. So dev0 is a special place where DD is going to go, and every time it checks, it's going to find the number 0. It's going to put those into a file called, we'll just call that file that it's going to go to root big file. And then we're going to say block size is equal to 1024K, and the count is equal to, let's say 5,000. So we're going to give it a 5 gig file being written. Oh no, I clicked the prompt on accident. That's fine, Liquid Man. I'll give you those points back. I realize you didn't. That's okay. I'll give you the points back. Because maybe you want the points to use some other time. All right, because we got other cool things with that. DD just writes, it's the disk duplicator. If you want it to write a bunch of zeros, that's all you got to do. In file equals dev0. Oh, it can copy files. It can be salty. You can use it for backups. You can use it for binary replacements of disks, a bit-to-bit exact placement of disks and copies. That's what we normally use it for. But by default, if you do something like this, it's just going to write a bunch of zeros into a big file, and it's going to be a block size of 1024K, so it's going to get 1 meg of them before it writes, and the count is going to be 5,000. So let's do this. Let's write, whoops, root big file. Sorry, that's out file, guys. What the heck's wrong with me? Don't listen to me. It's out file. And while I do this, let's go over here and look at this. We're going to see a massive amounts of kilobytes per second reading out into the system. Yeah, I meant to say out file. Sorry. Yeah, you guys were, I was testing you, and you guys passed. Excellent job, guys. You passed. I was testing you, and you were successful. Very good. Look at this massive kilobytes of write per second. And we are hammering the system as we go and write that out. And then it got finished. It got all finished. So within that time, that's all the extra time we were going to see it write. But over here, we see that we wrote at 327 megabytes per second down to that system. And oh, Salty, it's always a test. If I ever make a mistake, if I ever deign to make a mistake for my subjects, no, I'm just kidding. But if I'm ever, it's the same thing with my college students. I tell them, I did that on purpose. And only one of you passed. All the rest of you failed the test. You don't get a lunch. You don't get a break or whatever. And then I take their breaks away from them. So we can write out. We'll do this to like see how fast writes are into like our big file systems and stuff. And this is how we test the write. So now check this out. Now we want to read it in. So we could do a DD, and we could just switch it around. The in file. So I'm going to mess this up. I'm going to say the in file that I want to read is this. and the out file is going to be the trash can. It's almost like your dad. If any of you remember when you were younger, or some of us, we sat and read the newspaper. But it would be like if I just read the newspaper and then I just threw it away as I finished each page. Like I just let it fall right out of my hands right into the... This is going to read the big file, and it's going to read it in and just throw it out in the trash when it's done. And this will tell us how long it took to read all of those 5 gigs of zeros. By the way, if I come over here while it's doing it, look at this massive read that we're getting. We're reading that system. We're heavily pulling from that disk, that one VDA disk that we have. By the way, it's probably done over here. No, it's not done yet. So this is really high read, some other read. Yeah, I throw stuff into DevNull all the time. Yep, look, bam, massive read IO against one disk. I can tell it's all on this one disk. I already knew it was on the one disk, but maybe I needed to know that and prove that. And I read at 140 megabytes per second. Now, the next question for the astute reader is this. Is this fast or is this slow? And I'm going to tell you that depends. What we do in the systems world is we benchmark things. So I would benchmark this system like this, and I would maybe do something like this, right? So we'll go to our out file here, and we'll do, I'm going to make these a little smaller, so they'll just be 1 gig. And then over here, I'll make this a $I, right? And over here, I'll say done. And then over here, I'm going to make this a for loop, and I would say like for I in, and then maybe 1, 2, 3, 4, 5. Or I can just say something like this. This is another way of doing it, sequence 5. And then say do that. So now I'm just going to write 5 blocks out to the system. 5 blocks that are going to be incrementing in names, so I'm not writing over the same names. And they're taking whatever time they take, so I can get a few different outputs of my time, right? Yeah, you don't only do it once. We do have a Discord. Yeah, you can go hang out in the Discord. That's always free. Hang out, chat with other engineers, architects. Salty here is one of our kind of main coders, and that's what he does professionally. Yeah, so I would aggregate these right here, Salty. And I also have a chat specifically where we talk about, let me see if I have it here. Where is that? Is it this one? No, that was the cloud computing one. I'm going to get rid of that one. We don't want that right now. Nobody cares about cloud right now. It's here. On this one, I talk about benchmarking methodology and what that is. Hey, Hot Combo, hopefully this stuff's useful to you. Oh, is my system not telling me when you guys follow? Yeah, thanks for the follow. And hold on, so we come down here, and I have different benchmarking tools that we use, DD and stuff like that. But this is how I do my practical application of benchmarking, Salty. So right here, benchmarking methodology is planning, some experimenting, and then some improvement. And then we recalibrate and go back through it. But for me, stuff like this, let's say I run the backend storage for my storage area network for some Linux systems, right? And I may write this out. I may do this test a few weeks out, and then maybe a week before, and then right before I do some big, maybe I add new disks, because a lot of times you'll add like a new disk array because you're filling up or whatever. And I will do this, and I will get my basic speed test out of the way. And I'll write down what my speed was. What was my write? What was my average or whatever? And then I'll go make whatever changes I was going to do and improve the system in some way. And then I would come down here and I would rerun my commands. Whatever I did here, I would rerun this, but with new... By the way, I would always change the sequence number, so I'm always writing to new files. Because certain systems like GPFS and Lustre, they do weird caching stuff, so you always want to use new names. Very important, always use the new names. And I would see if I improved the speed. So if I expected to maybe have the speed faster, maybe this is a faster because it took less time to write, as opposed to this where I would want to see more speed, right? More speed is better in this case. Less speed and overall write time is better here, right? So less speed but a higher throughput, right? So my point is I would gather things, the first data, make my change, gather new data, and verify the delta, which the delta is just the change. What's the change between this thing and this thing? Is it better? Lustre is an HPC async read-write file system. First off, it's Lustre, just so you know. I'm just saying that in case anybody wants to look it up. It is a async. The client makes it look like it's locally mounted. I wouldn't call it async. And Salty, I was just saying that in case anybody else wants to look it up. Um, I don't. I wouldn't call it async because the client makes it looks like it's there, and it does have a pretty good read ahead, meaning that you can start to read files even before they're fully on your system. But yeah, I guess I'm not sure if async is in the name for sure, but it does pull things down and let you start reading them before you get it all downloaded. So that's actually a kind of value to it. Yeah, it's all HPC. That's where I've used it for years, is in high performance compute, absolutely. And by the way, you might say, wait a minute, Scott, do you really do? So you have like a 20 or a $30 million system, and you really do this to bench? Absolutely, effing do I? Hold on, you guys are making me sputter. Hold on, let's go to my streaming default here. Am I in front of the thing? Absolutely, effing yes, I do. You know why? Because vendors and their sales engineers and their pre-sales engineers and their actual implementation engineers and all these other things are going to promise you everything, but at the end of the day, the only thing that matters is how fast this system can write to it. It's the only thing that matters. Yeah, ask Salty right here, as a programmer, does he give a damn if I give him the white sheet of how fast I was promised, or the contract of how fast I was promised that this was going to work? He doesn't care. He does not care. Robodom doesn't care, or Robodom doesn't care. Salty doesn't care. Nobody cares about your problems. I need to get that. Hold on, wait. Where is it at? I got this. But no, I need to get Ice Cube yelling, "Korean Jesus doesn't care about your problems." The engineers that you support do not care about your problems. All right, I'm going back off stream. I was just messing around for now. They don't care. Nobody cares, right? All right. So enough of that. So the question was, can we verify the read and write speed? Yes, we could. And could we verify that the system was under heavy load when we were doing it? Yeah, we could see the kind of load that's, and then you say, well, was that load that was happening high? And I say, I don't know. It depends on your historical data. And by the way, it depends, if your system always looks like it's reading like this, and then it shoots up really high, well, that's a problem. All right, so that's that. Then we'll go into security topics. We'll do a little bit of security here. Skull Crusher, so weird question. If you have Linux running on a VM on a Windows box and run IOStat on the VM, will it be able to track disk usage on the disk from Windows tasks, or only tracking things being used within the VM? Skull Crusher, it will only see things on the disk that is being presented to it, which is a virtual disk and a virtual resource. It will not see what's happening on the underlying Windows system. No, it will not. It will not see that I/O. It will not see that throughput. In fact, almost all of its performance, in fact, all of this performance is happening against RAM, and this system is not actually touching a real disk anywhere at all. This system is touching a RAM disk that's been presented to it inside of the Red Hat 8.6 server or whatever that we're running. Yeah. So yeah, nobody cares about the problems. They don't care. All right. So we had security topics. I didn't even hardly start writing these, and then general system ones, and then we'll do some more. So let's do a security one. This is the fun security one for us systems engineers. So I'm gonna Control C this. The first one here that I'm asking you guys is, as a security topic, is what users have logged into the system in the last 24 hours? Can you tell me that? Do you as a systems engineer know how to do that? Why don't you think about that? Do we know who's logged into the system in the last 24 hours? Where might we go look for that? Last is good. Yep, last is a great one. All right, we'll type last. This tells me everybody that's logged in since the WTemp began on Sunday, November, whatever. If I do a date, okay, I'd buy that for $1. Then those are the only ones that have logged in. Where else could I go? Anybody else know where I could go? Last is great. By the way, there's one problem with last. Last is in descending order. It's the most annoying thing because the most current is the bottom. So some people, I like to do last, and on a bigger system, pipe it through more, and then it'll be in order. And then I also like to if you don't want to do it that way, you can last and pipe it through tac. Tac is cat backwards, and it'll put it in the right order for the top. Yeah, let's see. If you want to see it in ascending order, like we mostly like to do. Yeah, I don't ever tail it, but I'll do it. I'll do it with a more just to see kind of what's happened. And why is that? Anyways, all right, it doesn't matter. Yeah, tac is just backwards cat. It turns things around. All right, so to other people's questions. So var lib last log. Let's go look at that. More var lib last log. Oh, I don't have it on here. Ubuntu doesn't have it. But what it does have, this is a good one, var log auth log. Var log auth log is going to tell me everything since the last rolling of the log that has happened. So I see some things that have happened in here. It accepted passwords, and these things have been logged into the system here. So that's a good one. This is also really good if you have this logging out somewhere. Auth log should be going somewhere. Var log last log. Let's see. Can't read it. Can I cat it? It's not readable. But you also have var log wtemp. Yeah, that is that's hard to read. But that's the log where everything's being read out of. So you don't really go look at it like that. I appreciate that, Salty. Thanks for gifting the sub over to Cypher Enigma. So now Cypher, make sure you refresh so you don't get any more of those annoying things. Also, funny enough, I'm surprised I didn't change that over to. I should have that be do all the Linux, right? That should pop up like do all the Linux. Yeah. We type last. Last is the way we do it. That's the answer I was looking for. What's this? What users have logged in, right? But auth log is also a big one. And in the Red Hat world, Red Hat CentOS, Alma, Fedora, Rocky, I'm just naming stuff now. It's varlog secure. Varlog secure is where we normally where we do it. Yeah, we type lastly. All right. Okay. So, security topics. What other things might we want to know around security? So, all I asked so far was what users have logged in. But let's duplicate the slide, and let's say, let's do one that's a little harder. Let's say, what process? Can you tell me what PID is? What PID is listening to port 22 on your system? Can you tell me what PID is listening to port 22 on your system? Can you do that? Do you know how to do that? What is that? What does it mean to be looking at the PID? Can you tell me how the SSH daemon was started on the system? Right? Can you tell me how it was started on the system? All right, let's go down here. And can you tell me what PID, what process ID, is listening to port 22 on your system, and how would you go find that? Oh yeah, Cypher, I'm really glad you learned something from the labs. The labs are designed for you guys to just blast through them and learn stuff. Salty, netstat's good, but netstat doesn't work on these systems. We need ss-ntulp will help. That's a good start. But what if I told you didn't have any of those? Well, by the way, there's more than one way to do it, guys. Is it really always the same PID? Maybe for this box it might be, but in this box it may be because it was a cloned box. But what if I told you also can use lsof-i for port 22, and you can see which command is holding open, which process. So SS is a great one. SS is great. Look, port 22, boom, it's the SSHD daemon, and it's on PID 601. That's the process ID 601. Boom. It's listening here, and I can see a bunch of information about it. Also, I can do a ps-ef and grep for 22. Now this is a little more dangerous because this may pop up with a lot of stuff. But if I knew that it was SSH, maybe I may be able to narrow that down a little bit. That wasn't as good an answer. SS-NTULP will show you a bunch of stuff, and then you can look at this one. And there's my process ID 601. Boom. And there's the name of the process, or the name of the command that started it. Here's the process ID 601, right? Boom. And then maybe I want to dig in a little bit. So I say ps-ef grep-i for 601, and I want to get that process. And then now I can see how it was started. It's this user sbin sshd-d. And I say, okay, how did that got started up by this sshd daemon? And then maybe I start coming in here. Yeah, systemctl status sshd. That was going to be my next one. Fisherman stole my thunder. Fisherman stole all my thunder, guys. Now I got to quit. I can come in here. My environment's about to fail in 2 minutes, by the way, so I'm going to restart it. But yeah, here's all this information. I can see where it was loaded from. Here's the process that started it. That's the next question. Can you tell me how the SSHD daemon was started on the system? Your systemctl called this. libsystemd system ssh.service. Here's a little trick if you've never seen it. Systemctl cat sshd. The same exact command I just ran. It will read out that file for me and tell me how systemctl started this. There's the start command right there. That maps back to what we saw when we looked at that. That's the command that was called right there on our system. The salty catfish. I can talk about zombie processes. Yes, I'm going to have to reset my environment here in a second. If any of you guys want to follow along, here's all our labs. We are just going through and doing this stuff. Fisherman said it's $5. You know what's funny, Fisherman? For all the years I've been streaming, which is over 2 now, 2 in like 2 months, I have never set up donations. So like, yeah, you guys can do bits or you guys can do like the other stuff, but there's no direct donation to me anywhere. I always thought that was kind of weird. I always kind of felt like I was like sitting here with a cup out, and I'm like, that the reason that feels weird to me. But you know, I appreciate when guys like give bits or do stuff like subscriptions, because I think that's fun. But I can tell you guys for sure that you know, as a pretty well off Linux engineer and college professor, I feel very weird just like having a cup out and being like, hey guys, would you give me a little bit or whatever? You know, give me some bits or whatever. I always felt kind of weird about that. In fact, I even felt kind of weird, you know, setting a price on the book. But there is a book. It is the prologue stuff. I needed to charge something for it because if I didn't, Fisherman was gonna sue me for using his his image. But as it were, I think he's forgotten about it, so we won't mention it anymore. All right, but anyways, and I only use part of the engine as well, so or part of the image actually as well. So all right, I'm just kidding. But let's go in here. The logo is under business. Yeah, business source license. So as long as I use it for free, it's free. But if I get anything from it, then I got to flip you back a nickel. I agree. Okay, so the question was, can you tell me how the SSH daemon was started? So we did an lsof-i for port 22. If you've never used that command, tremendously useful command for seeing what is holding something open. So you do an ss-ntulp and you see something that's strange on your system. Why the hell is this port open? What is this runtime? I don't know what a runtime scenario is. What is this process ID? What is this? So I should be able to do an lsof-i on :4030 or 40,300, and I should be able to see that this thing is here. Here's the process ID for it, and this is going to blow some of your minds. When people say everything in Linux is a process or is a file, they're not lying to you. Proc 22385 exists on this system. I'm positive of it. And in here, in this directory I'm in, I can see exactly what the stack is. So if I cat stat or cat stack, I can see exactly what's going on with that process at any other time. At any time, I can see what's being used. I can see how it was called from the command line. I can see all kinds of things in here. Literally everything about that system is in here. If I want to see what kind of memory information, everything that's going on with this is right here. Okay? If it's waiting, how much memory it's using. By the way, this is where all your tools go and look. Top and atop and htop and all those different commands that people like to run. ps-ef. All it does is cd into this directory and look around at all the processes right here. All these processes are mapped to an actual process running. So if you guys didn't know that, allow me to demystify something for you. When people say everything inside of Linux is treated like a file, they are not lying to you. Literally everything is in here. Okay? It's better to look at it with tools, because, like, God, there's going to be a lot of crap. But it's, it's there. It is something you can go and look at. Okay? If you guys didn't know that, there's hopefully blowing your mind there a little bit. So, again, how was it started? System CTL status SSHD to see it. And I see that same process ID of 601, which is the one that I found earlier when I did my LSOF on 22. And I found that 601 was the process ID that was running. System CTL status, cat on SSHD will show me how it was called and what the file was. This is a readout of the entire file. I know that it came up after multi-user target. Multi-user target is level 3, right? Or it's a run level 3, right? And it came up after the network came up. So the network had to come up before SSH could come up. Well, that makes sense. How am I going to bind to port 22 and be open if I don't have it? By the way, that SSH right there that's being mapped from port 22 is being mapped out of your Etsy services. Remember earlier we can grab SSH from Etsy services. Remember I told you guys earlier that that's where that's mapped from? System CTL controls System D, Salty. System D is the daemon. So System D is the daemon that we run, and System CTL is how we control it. Now, that being said, hold on. There is System D commands. But System D commands are kind of funny. This is one of my favorite ones. System D analyze blame. This is one of my favorite things to show you guys. I was going to kind of pop this up later, but do that on your system if you want. This will blame the system for how slow it came up. This is one of my favorite commands. If you build systems, right? If you're like, hey, Scott, I want to get into, like, you said that you build a lot of images for high performance compute. First of all, let me tell you, that is not a glamorous effing job. That is a no thankful, just working down in the trenches with very little to no thanks. But if I needed to make this system boot a few milliseconds faster, yeah. So here's the way that this is in order of what took the longest to come up. So if I was in here and I was like, man, I gotta take 3 seconds off of this. I gotta get it, Fisherman, I don't use Packer professionally. I used to use Packer in the home lab here to show people how to build images and that kind of stuff, but I don't use it professionally, no. And I think, like most of the industry, we're moving away from anything that uses HashiCorp language. I think that's where it's going to go ever since they moved to the BSL, Business Source License. So, okay. But anyway, so there's all this, right? And it's down in order. And you could know what you need to cut out. By the way, this is an excellent way to see, hey, what kind of BS is coming up on my system? I want to run this as a real lean system. Why the hell do I have this Docker starting? Never mind the 700 milliseconds. If you tell me, Scott, I'm not going to run this as a Docker server, why the hell is that starting? And if you tell me, hey, Scott, you know what? I'm not going to be using our syslog service. We log our stuff out with Loki or something else. I say, well, I could save you half a second. And you say, is half a second really that big of a deal? Well, half a second is half a second, and when I'm bringing up 5,000 machines in a big cluster, the faster we get past things that don't matter, the faster we get to things that might error. And then, yes, it does matter. Everything matters at the end of the day. Okay. All right. So that's a thing. Okay. So can we see what Damon was? Okay, so let's keep going here on security. So we had what users have logged in. We had, can you tell me what process ID is listening to port 22? We did that. And then we said, can you tell me how SSH daemon was started on your system? Let's go down here and let's ask another one. This is general system, but this is also security. Let's say, can you list the kernel modules? Can you list the kernel modules? And then, as a corollary to that, can you tell me why kernel modules are a security issue? Lower bit also makes me attach. Also makes the attached surface small. Yeah, lower order bit. That's That's exactly it. Anything that can keep this down. You want to keep this down. You want to keep this only to things that you need running on a system for all kinds of reasons, but mainly for that. With that, yeah. I think Mu Time has it right. LS mod is one of our babies. LS mod is great. Let's show you, or let me tell you guys how I use LS mod in the industry quite a bit. LS mod will let me know if I have modules running that I need for different stuff to work. So, for kernel modules here, we've got this, whatever this RAID 10 is right here. And if we look at this here, it is not being used by anything. See this used by? All this stuff on the right, I think of as kind of like hanger-ons, however you want to think of that. But this RAID 10, if you said, Scott, could you remove that RAID 10 module from the kernel? I would tell you probably, because I don't have any hanger-ons over here. I don't have anything that's stopping, that's using it, really. So anything over here to the right is using the module that you're on. This is very important. If you're trying to install Lustre kernel, or the Lustre modules into the kernel, and you're trying to maybe remove them and re-add them, but they won't go away, and you go and you do an LS mod and you see things hanging off over here on the right, you've got to undo those you got to undo those first. So look, this RAID 456 is right here. If I remove RAID 456, so if I do an RM mod, or I should be able to do RM mod RAID 456, right? And then I do my LS mod again, I should not see that in there anymore. It's not there. Actually, it looks like it took a bunch of them with it. Where's it at? Hold on, down here. Yeah, I don't see it anymore. And by the way, you should also be able to do stuff like this. This is mostly what you do. LS mod. What's LS mod? grep-i. Achoo! Oh, man. Achoo! Oh. Yeah, by the way, my wife makes fun of me because I sneeze really loud. I try not to sneeze on stream normally, but yeah. Thank you. Thank you, guys. All right, so all those raids were removed. I have other raids, but not that 456 anymore because I removed it. Now, I should be able to remove any of those other ones. Those other ones all got ripped out as well. Fisherman, my wife claims she can hear me when she's pulling in from the garage, still sitting in her car talking to her friends. The garage is underneath my room in the house. While her car's still on, before the door is closed in the garage, she claims that she can hear me sneeze. Now, she's right, by the way, because she knows that I sneezed, but it doesn't make me feel good because she's making fun of me. All right. So, LS mod will show you things like that. So, can you list the kernel modules? And this kind of becomes really important. Like, you do an LS PCI, and you see if the hardware bus adapter. In this case, I see no hardware bus adapters. There are no HBAs. There are SCSI devices. So I've got SCSI controllers here. And maybe this SCSI controller is what I expect, but the SCSI controller is not, the module that runs it is not there. So maybe I got to do a mod probe to install, some module. And then, if some module existed, mod probe would put it in. And then we would do an LS mod and grep for some module. And we would see it running. And then hopefully we would be able to get our system working if everything was right? Skull Crusher, that's probably correct. That's probably somewhat correct. We got 2 people on YouTube, so maybe YouTube's having fun. I don't know. Maybe I should type something out to YouTube and say, hey, in the YouTube world. Maybe they're having fun over there. I don't know. All right, so I'm back over here. Can you list out all the kernel modules? Boom. And this is security stuff, because what's in your kernel is, again, you know, what's capable. It's just more attack surface area. There's no reason to have your system carrying a bunch of open software and ports and modules and things that aren't being used. Okay, so just think about that as you run systems. And then we come down here to general system. Let's talk about some general systems. General system and security stuff could probably be interchangeable. But let's say, can you tell me how the system was booted by grub? And this could mean a lot of things to a lot of people. But can you tell me how the system was booted by grub? Can you tell me the kernel version? And then let's make another one. We'll duplicate and let's say, can you tell me the version of Linux you're using? Can you tell me the version of Linux you're using? Oh man, so many general things. Can you describe the 7 fields of the etc pass to the D file? All right, so here's some general system stuff, right? This falls into, I mean, I break these out again later and stuff as well. But we keep going. Robodom, just glad your streams finally get recorded to a place where you can reference them. Robodom, I don't know how long live streams stay live on YouTube, but yeah, absolutely. Hopefully people find them and like them, and I'm probably going to need to eventually add descriptions to them that just point people back to the Discord. And Salty, I appreciate you coming by. Yeah, keep working on stuff. Keep doing this stuff. There's a lot of information here, right? I'm kind of dumping a lot of years and years of doing this on you guys, so you know, and we're trying to do it in a way that's digestible. The goal of all this, again, is, and these are all the topics we talked about, is just like the Socratic method, like a professor or somebody else sitting down with you and talking through these and asking you questions, and then you answer those questions or think about things, you know, and that. So by the way, there's a shout out for Salty. Make sure you follow Salty. If you don't, well, one, follows are free, so that should tell you something. And 2, he's the guy that I go to when I have like programming questions. He's been a programmer a long time. That's what he does professionally, and I happen to know him professionally as well, and I know that he's very good at it. I've sat in many of his talks on systems testing and systems design, and he cares about it more than I think most people I've seen do it, even streaming. So he's great to go and watch. All right, so general system. Can you tell me, can you tell me this system that we're on right here, can you tell me how it was booted by grub? Do you know, that'd be another fun one. Can you tell me what booted it? But really, can you tell me how it was booted by grub, and what commands might you do for that? And I show you guys this. I've done this on stream before, so I know that this is a command some of you are probably familiar with. But how do I go check that? Yeah, how do I go check that? Yeah, and Robodom, you know, you've worked with Salty, you know that he legitimately knows his stuff. Like I look to him for any kind of advice I need on that kind of stuff. Cat boot grub something? Yeah, maybe I just look for is boot grub there. Yeah, that's actually a, like, if I was looking for breadcrumbs, right, and I was trying to do forensics on this system, that is a really damn good indicator right there that the system was booted by grub. I like that. That's really good. That's a good indicator the system was booted by grub right there, that I have grub on the system. Right? It's not going to be Lilo anymore. That's gone. That's been gone a long time. Could be grub 2, but I think grub 2 is mostly Red Hat type systems. But I can come in here and I can look at this. But maybe, what if I asked you a little bit different? I said, can you tell me the command inside of grub that was used to boot the system? Does anybody know? I can think of 2 right off. And I'm not saying that to brag. I'm saying that because I want you guys to learn them. What are the ways that this system was booted by grub? What do you guys think? I can think of 2. Somebody mentioned one of them earlier for looking at how the system booted up in general. It's where the kernel ring buffer 0 or the ring 0 buffer, however you want to look at that. It's where the kernel buffer writes. That helps. It's before system D. No, not telling it. Let's do this. Do a D message and pipe it to head. And look real quick. How is the system booted? What's that command line up there? How is the system called? Now this doesn't necessarily tell me that it was booted by grub, but it does tell me the boot image and the command line that was given. Okay. This is the very first thing that happened from the time the kernel was first called, right here. And then everything that it did as it walked the bus and made sure everything was working. How about this one? Cat proc CMD line. Cat proc command line will tell you the command line information. And one of the reasons I tell you guys this, and I think that this is so important, is if you build 100 systems by the exact same process, you should then be able to go over those systems and check, and they should all be booted the exact same way. And if they're not, that's a problem. If I really wanted to, I could grep. Let's just grep generic from boot grub everything. And in here you can see that that is actually, and if you were like, well, that hasn't proved it yet, but this could prove it. The boot image, the boot line that was called right here, the boot image of this system as the kernel started is the one that came directly out of the boot grub config. So I could say with reasonable certainty that it was boot that kicked this system off. If we were like playing a forensics game and I had to prove it to you, I would say, well, I've got this, and I've got this from when it started. Pretty good chance it was this that kicked it off, right? As a menu entry for Linux, right? So this is, something. All right. Can you tell me the kernel version? What's the kernel version I'm on? What are the ways you could find the kernel version? It says we're on ad break, so I'm going to do an hourglass. Actually, I'll just do this. Sleep, 120, ad break. That's good enough. All right, ad break. I'll be right back. All right, ads break almost over. Ad break is almost over, and then we'll get back to it. Some of you guys don't get ads, some of you do. Cypher Enigma. Well, I'll wait a second here. Okay, ad break should be over. Cypher Enigma. I don't do a lot of DFIR. I don't think I've ever. Wait, somebody showed me that before, and I think. I don't know. Oh, no, I don't. Cypher, I don't as much anymore. Let me tell you what I have done a fair amount of in that space. I've done a lot of data gathering over the years as a, because I've been the principal on a platform engineering team, and I can tell you, like, do you need more information around that? Because I can give you a lot of information around that if you want to know digital forensics type tools and stuff to use. But no, I don't do a lot of that anymore professionally. Do I understand the process and getting the thing and pulling it off the network and making sure that we have good forensics around it and stuff. No, I don't do that very often professionally anymore, though. Have I done that? Yes. Um, I worked with that quite a bit when I was the lead of operations, because I've told you guys I spent probably about 6 or 7 years total as the platform engineering lead for AAA. So I ran their Linux engineering and their Windows engineering teams from like the design and build and all that type of stuff standpoint. I kind of just ran all that. So I did have to do a lot of this, but no. I'll tell you a good place to start though for people that are like, I want to get into that more and I want to do that more and get better at that. There is a good thing on sans.org specifically around their ultimate list of cheat sheets. Or maybe you tell me, hey Scott, I want to get better at that stuff and incident response, digital forensics, looking at systems that I've had problems and my team's very bad at it. Go here. So I'm going to link this to you guys and start down here. And some of these are like cheat sheet for internet applications, and they're cheat sheets, but what they are is they're a way to start you looking at how you might go and look at, like, so if a server is suspected of being compromised, these are the things that we're going to start doing on them to go see what's going on. So here's our Linux ones over here, and here's our Windows ones on the left. So the Windows ones are this left part and up here, and then your Unix and Linux ones are down here. Yeah, this is one of the best things right here that you could spend time in. And you could build a procedure from this. So you could come in here and you could turn this into, like, and by the way, it tells you that you're allowed to use them. It says, hey, you know, but really I like this. It's need help cutting through the noise. They're quick references. And then you turn those down into procedures that then people can go through. So if you get called in the middle of the night, you pull out that procedure and you start going through it, right? Here's our network DDoS incident security response sheet. How do we deal with that? What's being affected on our system? What do we check, right? Because a plan is just a list of things that don't happen. You need to be practicing these things and you need to be getting good at them, right? So the question over here is, can you tell me the kernel version? And the command was uname-r, uname-a. Uname will give you some information. I think uname-m was one that somebody gave the other day, so you can get the actual version. And then now the next question, I don't know, will that one show it? I don't think that'll give us the kernel version. But that is my next question. Can you tell me the version of Linux you're using? And that's cat etc splat release. That's one of my favorites. Yeah, Cypher Enigma, you gotta practice this stuff. You gotta get good at your tools and use your tools and figure out how these things work. And yeah, so can you tell me the version you're using? We're on Ubuntu version 2004.5, right? And here's some other support URLs and stuff. And we're on the long-term support version, so that's good to know. Maybe that matters for us in our company for how we want to plan our new server deploys and that kind of stuff, right? No, that's fine. That's fine, time. You're good. So what's our next question here is, can you describe the 7 fields of the etc pass WD file? That even sets up a simpler question. Do you know how to check them? You could do a head on etc pass WD. You could do a cat on etc pass WD. You could do a more on etc pass WD. You could do a tail on etc pass WD. You could do a less on etc pass WD. You could do a VI. You could do a view on etc pass WD. You could do a VI on etc pass WD. You may even be able to get away with a VIM on some systems. Look at all these ways I can check this system. Those are the ones that I just thought of right there. I could do a head, I could do a cat, I could do a more, I could do a tail, I could do a less, I could do a view, a VI, a VIM. I could even do a tack. Tack is going to do it backwards. And then I can pipe that through a head, right? So I just get the first 10 lines of that, but that's backwards, right? There's a lot of stuff here, yeah. And Cypher, I'm a big fan of just getting in here and typing these things out and learning as we go. I tell you guys all the time, if you had 2 friends that go to the gym all the time, and you stopped them one day and were like, hey, I want to start going to the gym. They're not going to sit you in the locker room, with all those old guys in there drying themselves off and stuff. They're not going to sit you in there for 6 hours and tell you about lifting weights. They're going to make you come and follow them around in the gym. And I tell you guys, this is not hyperbole. This is how we learn. Like, some of us learn, and again, this whole thing today has been around how you learn, and the goal of this was to kind of talk through the Socratic method, right? I'm just walking you through and asking you questions, and you guys are throwing out answers and stuff, right? And we're way down. We're way down here in way down here in the general one, but we were looking at what's the version of Linux that we're using, and now we're looking at these 7 fields, right? Less is best, widely available even on extremely old machines. Okay, so I'm going to clear the screen off, and I'm going to say, can you tell me about those 7 fields? So we head etc pass WD, and we look real quick here. There are 7 fields. The field delimiter for this is the colon. Most people call that a field delimiter or a field separator, FS sometimes, field separator. Some people just have it as D as a delimiter, right? Yeah, so what are the 7 things, right? There's the user name, that's the name. There is the password, but an X denotes that the password is actually found over in etc shadow. There's the user ID field. The user ID is the way the system maps back to who owns files. Then there's the group ID of the primary group of that user. That's the primary group ID, but it's just called GID, group ID. Then we've got a description, which is a field that can be empty. You can have an empty field there. In fact, I think one of these is probably empty right here. Do you guys see an empty one? I don't see an empty one being used, but it could be empty. And it can have spaces in it. All of them could, technically. Here is the home directory of this user. That's field 6. And the 7th field is the default shell of that user. So, sometimes we like to lock users out. So one of the questions I might ask from this, and may probably would have been better as a security one, but let me ask you this. Do you, from just looking at this right here, could you tell me how we might lock a user out from getting into our system? If we don't want a user to ever have shell access, it's a user that's allowed to be on the system, like bin and sys can execute processes, but they should never load a shell. Nobody should ever log in as one of them. So what might we do to their shell, specifically? Set their shell to user no bin, user sbin no login. There's also, by the way, there's probably a whole bunch of them. And let me show you guys how I might find all of them. So here this could be a little bit of a challenge. So I'll add this as a challenge question. Hold on. So PID, process, general system, hold on. I'm going to go to this second to last question. I'm going to make one more that's going to be hard. Can you show me all the unique shells that exist in etc pass WD? I just want the unique shells that exist in pass WD. Can you show me just that? I'll show you in a second how I would do it. Hold on, let me get this back to that. Okay, so can you show me all the unique shells that exist in pass WD? It's the 7th field over here. How would you show me just the unique shells? Does anybody? I'm going to give you guys a second to think about that. You can cat etc pass WD and see that there's a whole bunch of them in here. Bin false, that's one of my favorite ways to do it. There's user sbin no login. There's the actual look at this one, bin sync, that's fun. Bin bash is one. You can also just have bin bash, bin sync, user sbin no login. Sbin false is one of my favorite ones, and bin false, you could use either of those. You could also have it be dev null. It could be a trash can. But what ones are represented in this file, and how would you find them? So this is a little bit of a challenge question for some of you. And if any of you are sitting around and going, I don't know, well, wait for one of these smart engineers that have been, not even necessarily that anybody's smart, they've just been doing it longer than you, right? So let's look at one of the ways that they might do it. So I'm gonna clear this up. I'm going to do a head so you guys can see the format and the structure of the data, and I'm going to start taking it apart. I'm going to cat the full file out first, etc pass wd, and I'm going to catch it at the output before it comes out to the screen, right? Hey, there's our labs. Robodom's dumping labs on you guys. There are 52 labs that you can go do without me around. And then if you want, you can go on our Discord and you can yell at me about problems you're having with them. I'm perfectly fine with that. I want you guys to get in here and do this stuff. I want you guys to get in here and cut your teeth and learn this whichever way works for you best, okay? Now I gotta do something sneaky. I'm gonna cat etc pass wd, and then I'm gonna awk, and I'm gonna look at that data, and I'm gonna say the field separator of that data is a colon. And I'm gonna say now print $7 if I only wanna see, $7 if I only wanna see that last field. I'm gonna do it like this. Look at that. So now, let's clear the screen up. Go back to just our head of the password to look at our data. I got just that field, right? And I'm just gonna go ahead and do a head on this one so you guys can see just what it did there. But now I'm gonna take that off. I'm just looking at the data, right? I'll show you how awk works in a second. I think meow time got it, or moo time got it. That's it. That's exactly where I was gonna go. Now, after we have this, we have to sort them so that they're in order. And I'm gonna go ahead and throw a head on that so it doesn't give me too much data. Now I've sorted them all in order, and then I'm gonna do a unique on them. And those are the ones. Those are all of the unique ones. Now, I'm gonna ask you guys a question that may be kind of fun too, and time. You can answer this one if you know it, or you can let them figure it out if you want. I don't care. How can you give me a count of all of these? Can anybody give me a count of all of these? You can tell them if you want time. I'm okay with that. I want you guys here. I want you guys to see who you need to ask questions to, right? The people that know this stuff are the ones that go bug in Discord, not me. No, unique wouldn't help us, or word count -L now wouldn't help us. We're way past that now. So I need something else. -C is your count. Yeah, there's our pinned lab. Robodom, when you pin that, by the way, you should be able to see that you can set it to be the, however long people need or whatever. Guys, we're in that lab. We're not actually using that lab, but that is one of the labs. I'm actually just using it as a sandbox. So we're just asking questions and going through stuff, right? And this is, again, hopefully this is like super valuable to people who want to get better at this. Like, come in here and answer your own questions. Figure this stuff out, right? Figure out how this stuff works, because it's definitely something that you can get good at. Everything I showed you in here, probably not everything was used today, but everything in here I will use this week. Everything I showed you here, there's no point where you get to like time here, or any of you guys that have been doing this for a while. I don't want to call anybody out, but if Fisherman's still around, he was a Linux engineer for a long time, and he went and got some of his Red Hat certs, and now he's over on he's doing what's that called, oh shit, whatever that thing, he's doing a solutions architect for a big cloud company now. But my point in there is, like, for people that don't do this stuff as much, I want you guys to know that, like, you can learn how to do this stuff. You can do this stuff. What was I going to say about that? Oh, yeah, all these things that we did today, though, you're going to use in the week of doing this as an engineer. This is the stuff you're going to do. All this stuff that's in here. All right. So let's go back up here. For people that got here late, we'll do it quicker, but we'll run through it, right? We'll run through it, and this will be a review for people before I kind of get done here. Well, shoot, the wife's not going to be here for a while, so I guess I can keep hanging out for a bit. But let's go here. Let's look at this. So, learning Linux through the Socratic method. Let's see if you guys can see that okay. Yeah, you guys should be able to see that okay. And I'm just going to run through it. CPU topics. Can you list the number of CPUs? We said nproc, cat proc, CPU info would show you, but that would be too much information. So maybe you would parse it down to just grep -I for proc, right? And that'll give you that. Boom. Cypher, that's all I do. I tell people all the time, Cypher, look, And for people that know me and have been around and stuff, I also do this sport called Brazilian Jiu-Jitsu. I've been doing that for 20 years. And I have friends that tell me, like, oh, Scott, you know what you're doing, or you've been doing it a long time, and they'll come back to me later and they'll be like, everything you showed me works. And I'm like, yeah, because I don't know anything that doesn't work. I have a tiny little brain. I only remember the stuff that works, guys. So I have friends that they'll come back to me later and be like, everything I use is stuff that you showed me over the years, and I'm like, it's because I only showed you stuff that works. Anything that didn't work for me, I throw out. All right. So can you tell me the speed in megahertz? Boom. There we go. Megahertz. More importantly, could I do something like this and grep MH and then run that against a bunch of machines to make sure that they're all the same? Yeah, I could do that. Because look, all these simple things that we do against one node, we just do with like Ansible or some other tool against a bunch of nodes later. Yeah, like this is all stuff that I think you guys can learn and do. Can you tell me the manufacturer of the CPU? Well, this says Intel. I can also look up DMID code. DMID code is one of the best commands I ever found in the Linux world. DMID code tells me stuff about what's going on underneath the system. And to this system, this wasn't a great place to find it, but maybe I did find it in here. Hold on. Did I find it down here in the kernel? No, I didn't find the kernel in here. But I did find it in the CapProc CPU info, right? It's definitely in there. There's my model name for the CPU that I'm on. Boom. So I can tell you manufacturer. Can you tell me the architecture of this chip? I see the architecture right near the top of this somewhere, don't I? It's a 64-bit one, and should be able to see architecture up here. Why am I drawing a blank now? Where's my architecture, guys? Somebody help me out here. I can tell that it's 64-bit, but oh, uname -R, uname -A, uname -M will give you the architecture. So there's the architecture of the chip. That's a way to do it. Why am I thinking? Yeah. I don't know what the heck's going on with me. Huh. Where's my? Oh, I'm in a totally different one, so I might not even have any. I was looking for history on a system that's been blown away a few times, so it's not there. But architecture, I see my architecture right there, x86-64, and that's good. It's good enough for me. Can you tell me if the system is physical or virtual? What was the really good one that you showed earlier? Who time? System CTL. System D something. That was a good one. That was one that Time showed us earlier. System detect vert. I also look in DMI decode grep-I for KV. Oops. I normally do prod, and they'll tell me that it's that, or what was vert? You can sometimes look up vert, and you'll see that it's a cube vert manufacturer or family or whatever. So that's system if it's physical or virtual. Then we come down to memory topics. Can we tell how much RAM we have? How much RAM do we have? Free-M. You could also cat proc mem info. That's going to be a lot of information, but there's still info in there, right? Free-H was also used. Free-H was something that was mentioned. You can throw a T on any of them to get totals, right? And then you can see what's kind of going on in your system, right? Can we tell how much RAM we have used? Yeah, there's our used RAM right there. I again like free-M a little more for right now, because that's a way that I like looking at the data. I can also see, how much free is over here, and then how much is used, right? Can we tell how much we have free? Yep, there we go. Can we tell how much swap we have? There's our swap right there. We don't want to be using swap if we can avoid it. One thing that I didn't ask is, can you tell me where swap is mounted? Can you tell me how swap is mounted on our system? So, where is swap being mounted inside of our system here? Oh, your vert check command? It was right here. And that came directly from, one of our people earlier, Utime, mentioned that. System dash detect dash vert, and make sure you put in your command too, in your system if you got one. Yeah, that's the FS tab. We haven't even been in there today. If the system had swap, a lot of times it would be mounted out of here. If it's not, I can mount grep-i for swap and see if it's mounted there, and then I can do swap on -s to see where swap is happening in my system, right? If there's a swap file and what's going on with it, right? You can go look at that. I don't do a lot with swap anymore. We mostly just set swap to try to keep it from happening best we can. Alright, so how much swap we have. How can you clear all the free memory out of cache, right? So I showed you guys that. So we clear, and then we say free -m, and we see, what's all this damn buffer cache over here? And we might do a sync on it, and then we say, that didn't help us any. So then we echo 3, oops, 2 or 3. It doesn't really matter. It does matter, but it also doesn't. It doesn't matter so much. If I could type, geez, my hands are like just not working. Proc, sys, VM, drop caches. And if you do that, and then you go look at your free -m, you'll see that your buffer cache was immediately wiped out. All right, can you free all of the cache memory? Yeah, we freed it all up by erasing it. Networking. So let's go over to networking. Can you show all the interfaces on your system, right? We did a IP adder. IP adder is a great way to show those interfaces on your system. You could also do if config on many Linux systems, but not on this. So IP adder is probably your best bet. Yeah, so that's a good enough one for that. I said, can you show all the interfaces, and can you show that the interface is connected physically? Yeah, even though it's a virtual machine, it's still got to be connected into a virtual switch, and that's ethtool. This is such a useful command. Ethtool enp1s0 would show me that link is detected, yes, and is not turned off inside. Like, your port can actually be turned off even on a virtual machine and not connected to a virtual switch. If you didn't know that, try going and moving around VMDK files in a network and tell me if they always connect when you go to a new ESXi host. They don't. They literally don't. So, all right. Can you determine your default route, IPR, or IP route, as it were? Same command, same basic thing, and it'll give you a bunch of information there. Hey Jesus, thanks for the follow. Hopefully this stuff's useful to you. We are running through really quickly to kind of review all the stuff that we did earlier. Can you ping the default gateway 3 times? We could ping the default gateway a bunch if we want, but ping-c3 172.30.1.1 is our default gateway, and yeah, we can ping it. Some other things that I didn't even do. I like that. I like the first time chat there. That's pretty good. I love it. Okay, so what I didn't even show you is some troubleshooting that I like to do as an engineer. I'm gonna add some questions here. Hold on. So under networking, back under networking here, where we were doing, can you determine your default route? And then we said, what file do we change? Okay, so here I'm gonna say duplicate slide. Come down here. Can you prove that DNS is working? So can you prove that DNS is working? Yeah, we'll keep going with this, but for now, can we ping our default gateway? Can we properly identify all of those things? Okay. Can you list your open? Oh, I jumped way down. Hold on. We ping the default gateway, then we'll go back here so you guys can see this again. All right. We pinged our default gateway, and then can you properly identify all of your IPv4 and IPv6 networks? Let's do IP adder again, and we looked at this. Here's our loopback. That's home. 127.0.0.1 is always home. All right. 17, and then by the way, this is also home for IPv6. ::1/128. That's your home, right? Boom. ENP1S0 is going to be your primary interface, and it is 172.30.1 for the network portion. I know that because there's a /24, and the /24 determines that the first 24 bits are masked as network bits at 172.30.1. That means that this is the host portion over here, and the mask, if anybody cares, is 255, 255, 255, 0. Those are the numbers there for the mask portion. And if any of you guys ever want me to go over it again, or actually, fun fact, this is what we just put up on YouTube. If you go to the YouTube and you look at networking primer, the networking primer, and we have a YT here, that's our YouTube command. Okay, so in that channel you should be able to find the Linux engineering stuff, and I did a big networking primer where I go over how IPv4 subnetting works. So if you struggle with IPv4 subnetting, I've been teaching that at the college level for 15 years. I'm pretty good at it. I passed my CCNA 21 years ago, over 21 years ago, almost 22 years ago now. That's a long damn time ago. All right, anyways, I was only 21 at the time. In fact, actually, I was 20 when I passed it. Let me look. Let me think. Born in 81. Passed it. No, I think I was 20 when I passed it. Yeah. And then I went to Iraq, and I don't remember much after that because I was an infantry guy. So, all right. So we properly identify all of our IPv4 and IPv6 networks. Can I list my open ports? SS-NTULP will show me all of the ports that my system's listening on. This is my attack surface. If you said, hey Scott, could you identify for the company all of this, maybe this system Ubuntu is out in the DMZ. Can you identify all of the things that are dangerous, all of the ports that we need to block and make sure that we're not allowing out to the world? One, I would ask you, why is it in the DMZ? But that's neither here nor there. I would tell you, yeah, I could do that. I'm going to do the same thing that we did earlier. We did awk. Somebody asked me to talk about awk. I can do awk if you want. So I don't need the field designator because I'm going to use spaces for my fields. So this will be my first column. Any spaces will denote that I'm on the second column. Third, fourth, fifth. So I want awk, and I'm going to print $5. Whoops, $5. Awk is one of those ones you just kind of pick up and learn as you go. But awk carves columns for us. Columns can be noted. In this case, I'm doing by spaces. So I'm getting 1, 2, 3, 4, 5. I want this fifth column. If I want, I could just look at my data. Are my data coming out correctly the way I want? Yes. So now I want to, so you're going to use it for a column. And then now I've got to split this. I need to split it, but now I got to split it on the column. So awk -F colon, on a colon. I want to split on a colon. By the way, it can touch if you want. I don't really like them touching, so I do it like that. And then now I'm going to say print $2, and then I'm going to do sort and unique. And now I could show you right there and tell you for certain that those are the ports that are open on this system. Right there. Yeah, Cipher Enigma, that's about all I use awk for the most part. You could do it for some logic. There's some logic we can use in there if you want to see it. But yeah, I can list all the open ports on the system. I can tell you how this system is listening to things and all that kind of stuff. Could you snag it? Yeah, absolutely. Come on, right here. Especially if you're using a system where you can see the output. Yeah, there you go. There you go. SS-NTULP. You can man awk, but yeah. And there's a lot, man, there's a lot to awk. You can do, awk is a full programming language, guys. Just so you know, in case you don't know. Sed and awk both are full programming languages. In fact, I have Mario running in my home lab that somebody wrote the Mario first level in Sed. And I can't pull it up right now because we're on the alternate. I'm on my backup internet. For you guys that missed it earlier, I tried to stream on YouTube and Twitch today, which I am streaming on both. But my damn internet, which is Cox and terrible, went out. So I'm on my backup internet because, you know, I'm an engineer and I have two internets that come in my house. I'm an engineer and a college professor. I do both of those things from my home for the most part. So I need to be able to be on. And so I jumped over to my backup internet, which is CenturyLink. And CenturyLink doesn't know they're a backup internet because I just jump on them whenever I need. But they probably wonder why there's like bursts of a lot of traffic and then no traffic in my home lab or in my home system. But that is what it is. All right, I got 10 minutes left on this environment before it's going to reset. But we listed our open ports. Can I prove that DNS is working? So I added this one. We didn't do this one earlier, but let's look on our system, and I can look at Etsy resolve.conf or resolve.conf to see where my system is gonna look. Name server 8.8.8.8 is maintained by Google, and 1.1.1 I believe is as well. But that being there doesn't mean that DNS is working. I could ping -c1 www.google.com, and that'll tell me that I was able to resolve Google to a name. But some of you probably realize there's more than one way to resolve inside of a system. I could be using DNS, but I could also be using, let's grep Google from Etsy hosts. Is that in my Etsy host file? No. So it's not there. People are giving me some good answers. So I'm giving you guys some time to work on stuff. There's a few other ways we can check. We can do host for Google, and that may give me some information. I can also do an NS lookup for check the man page. I needed help because it wasn't true. Yeah, Cypher, I don't even dig down into awk very much. I just use it to cut columns. I can also use it for a few other things, but I'd have to think about them because I don't do them very often. NS lookup, www.google.com. Now, I get, it tells me where I went and looked, 8.8.8.8. These ones, host and NS lookup, prove to me for sure that I'm out looking at the network and the world. So host, www.google.com, NS lookup. Pinging will tell you the resolved name, which is very useful, but that resolution can come from your local host file. And you might say, well, how do I know what order my system resolves in? Well, this starts getting deep in the weeds, but this is what we're doing here, right? Cat Etsy NS switch.conf. And in here, your hosts that you're going to look at, your system resolves first to the files and secondly to DNS. So if I were to grep Google from Etsy hosts and see it's not there, then the next place it would look is DNS, right? I read the field manual and it's hard. Yeah, Cypher. Can I show you, Cypher, can I tell you the best thing to do instead of reading the field manual ever in Bash? tldp.org. Just type tldp.org into Google and then say awk. And awk is well documented in there, but I would call this awk by the numbers. Like, here, I'll link this to you, but everything that you want to learn about. So you're like, oh man, I don't know how to do, so there's a thing that I have never committed to memory, guys. I will never, and you can laugh at me until I've been a Linux engineer for 50 years, I will never commit this to memory. TLDP file test. I will never commit test operators to. Do I know some of them? Sure. Will I ever know all of these? No. God, no. Why? Why would I? I have the reference right here. Now, I realize that that's the same argument that all of my students argue with me on everything, but there are some things you need to know more than others. But if I want to know how to test that a file exists, or that it exists and, well, this one's a little bit different, it's deprecated, and I want to make sure it's a directory, boom, -D. I do know most of these, but I'm just going to tell you, I'm never going to bother learning all of them because I don't care. And there's a reference for them, right? So anyways, my point is, there's a bunch of stuff, and tldp.org is one of the best places to go and get more information on it. All right. So can you prove that DNS is working? I think we proved DNS pretty good. +1 for man, control byte. I between TLDP and W3 schools, I mean, I probably reference those two things more than probably just about anything else. For simple stuff, for like simple, stupid stuff. But I do it though. Sheet.sh to stay within the CLI first, yeah. And TLDP is great, guys. It's a really good. All right. What file do we edit to change the service port number mapping? I mentioned this earlier. So grep Etsy Etsy services. Services. Whoops. So grep SSH from that, and you'll see that it's mapped, and then you could use that to go mess around, right? Disk topics. So we talked about all these different things. Disk topics, right? How can you check how many disks you have? You have fdisk-l. Will give you a lot of information, but there's my one disk, and there's the devices. We had lsblk, lsb, and then what was it? Block ID-f, I think it was. Oops. Or was it ls block-f? Yeah, this one gave us some good stuff. And then block ID gave us some good information. We can see a lot of stuff going on in the system, but we've got one disk and 3 partitions to that disk. Boom. How many disks do you have? Can you check how many partitions you have? Boom. There you go. How do you check what file systems are on the partitions? Boom. There you go. We can see what's going on in here and what's the file system type that's written on there. We come down a little bit. Can you check for partitions that aren't even mounted? Yeah, there you go. Both of these will give you block ID, and ls block-f will both tell you the file system types that are on that system. All right, so there's different ways to find these pieces of information. Can you check the I/O over time? Yeah, and we did an apt install -y for sysstat. Right. If any of you missed that command earlier, it's right here. There's that command for anybody that needs it. apt-y install sysstat. I guess I should probably be dropping those over in the chat over on the YouTube side of things too, I guess, but there we go, boom. And then how do you check the disk over time? Once we've got that installed, we do iostat -d to just see the disks, and then we can say 1.5 to look at the disk throughput every 5 seconds, or sorry, every 1 second for 5 iterations, right? And then we can just say 1 second for perpetuity, and we can do that. And then what's the next question? Can you verify disk read and write speed? I showed you some dd commands where in file was equal to dev 0 and out file was equal to like root big file, and then the block size was equal to 1024k, and that's 1 meg, and count was equal to like 1,000. And I said, can I verify how fast the system writes? By the way, you always have the time command. Time is like a little stopwatch that you wrap around it. So time will give you even more information. DD already has a timer built in, but time will also verify that that time is right. I know I'm not supposed to crush those on stream, but gosh darn it, sometimes I just have to do it. All right, so it wrote in 1 gig at 50.8 megabytes per second, and that's a gigabyte that was written in. And it took 20 seconds here for our system. 20 seconds, 20 seconds. There's a little bit of a discrepancy, but not enough to care. It's 3/1000ths of a second, so not that big of a deal. In fact, probably closer to only 2/1000ths of a second. So not enough for me to care. It's not like I was sitting around waiting for it. Time is one of my favorite commands. If I have to give this to like a junior engineer to run later, and I know that some things are going to take longer, I will time my commands in my dev environment when I'm testing them, and when I'm testing how long something takes to install or to build or to run or to fix or whatever. And it's not because I want to be like, I'm so smart, I can do this. And it's not even so that I can leave and come back later when I'm running it. It's because I don't want that engineer to worry that a command takes 7 minutes to come back. 7 minutes is a long time when you're looking at this. Yeah, I'm going to tell you guys right now, if I stop talking, oh, my environment died. All right, my environment died. All right, I got to go back in. But if I just sat here and didn't talk for 7 minutes, I guarantee you most of you would leave. 7 minutes is a long damn time to sit and look at this. Terminal just sitting there. Yeah. So it's a really good, it's a good sanity check. It's good for your notes. Good for yourself too, not just your engineers. But I'm going to tell you, if you don't want to get called out in the middle of the night when your engineers are doing their work with their procedure that you put together, it's really good. Ports 1, hopefully this stuff's useful to you. Thanks for pulling up a chair. We're just kind of hanging out and talking shop. I'm running through our stuff that we did earlier, but we're just doing it again. Hitting security topics. What users have logged in? We determined that was the last command. That's really the best command for that, right? Can you tell me what's listening to your process ID for port 22? LSOF is the king of that. For port 22, there you go. But if you wanted to use another command that you're used to maybe grep out SSH and then C and verify, yeah, there's port 22 being listened to, and there's the process ID of 601 over there. 601 is the process ID that's listening to that port, right? 22, it all maps together, all right? Can you tell me how that SSHD daemon was started? System CTL status SSHD, and I can see the process running. It's active running. I can see that it's enabled, so when the system boots, it's always going to come on, and there's that process ID of 601. Okay. I can do a system CTL cat for SSHD, and that will tell me what unit was called and how the system was called, and here's that start for that process. If I do a ps-ef grep for 601, right, that's going to give me that, and there's that call of our system being started right there. Exec start right there with whatever options that were set in our system, right? Can you list the kernel modules? lsmod. Importantly, on systems, I might want to just see like word count -L to say 79, and then maybe I look over all 100 systems that I have and make sure that they have the same 79 kernel modules in there. Then we came in here earlier and we ripped out the what was the ones that we ripped out because we didn't want it anymore? It was a RAID one, and it was not RAID 0 or RAID 1. It was like RAID. There was one for a specific. Oh, RAID 456. We pulled it out. But what I couldn't show earlier was if I tried to remove this async mem one, since there's other ones that are using it, this will not remove. Yeah, it was RAID 456. So if I do an RM mod or mod probe-e, mod probe-e will also get rid of it, right? Whoops. And I paste. This will not leave. Whoops. Mod probe-. Huh? All right, we'll do RM mod. just use RM mod, whatever. And it said you can't use it because look, it's got these ones hanging off it. So this is one of these reasons why I said you can come in here and you can look, and if there's a hanger on over here, you can't remove this. But if you remove this, then you could come in and remove this. I think all these got removed earlier anyways. But it'll it won't leave. These are all like a little shunt in the door that won't allow the door to close for you, if you want to think of it like that. However you think of it, just know that if you've got something that's used by, you cannot remove it. I cannot remove this until I get rid of these two. Once I get rid of these two, this one's fair game. And they're not being used by anything, so I could remove them. Don't want to, though, because I don't want to mess up my network. All right. General system. So can you tell me how the system, or that the system was booted by grub? We can ls boot grub. See that it's there, so that's a good indicator. We can grep. What do we want to grep? Kernel. I don't know, just VM from boot grub.conf or .configure. That's the main one. And then if I cat proc cmd line, you know, this may be something that would show. Skull Crusher, I was surprised by that too, but just know if you're pulling things in and out of the kernel, you're probably going to get weird behaviors. We typically only do that when we're installing and building like systems and want to make sure that like they come up like a Lustre module. That's typically when I muck about down in the kernel, or when I build like a HBA, like a hardware bus adapter driver for like a kernel, or like the InfiniBand drivers for specific kernel types, and I build them and then I load them to see that they'll load, and then I reboot the whole damn thing because I want to see it come up clean before I continue on, you know. So we proved that the system booted from grub. Good. Can we tell the kernel version? uname-a, uname-r will give you just the kernel version, and that's something that we'll use sometimes in our scripts to make sure that we've captured the kernel version and can print it out to a log later or something like that. Can you tell me the version of Linux you're using? Cat etsy splat release. That is Shift 8 or the splat or the asterisk or whatever you want to call it. And there we go, we got the version. Can we describe cat Etsy pass WD? Can we get in here and describe what's kind of going on down here? Yeah, I think we can figure that out. We knew that there was the name, the password, but the password's kept in Etsy Shadow, the user ID of the user, and then the primary group ID, a descriptive field, that's a description, that's arbitrary, and then you've got your home directory and your shell that is able to be logged into. Splat, huh? Yeah, bang is this. Bang is exclamation mark. Splat is this. So bang and splat, if you hear them. All right. Can you tell me all the unique shells? And we had to do a little surgery here, but we'll do it again. Let's head on Etsy pass WD, and then we're going to cut. Huh? This question mark? I don't know if I've ever heard that, but that may be true. Let's cat Etsy pass WD, capture that output. We'll awk with a dash capital F for the field separator, and we're going to print $7, right? And then we're going to do a sort and a unique on that. And then if we wanted to count, we'd add a C. And that'll give us a count of how many of those can log in or whatever to the system. Okay? And then questions. My contact information is join our Discord, right? So join our Discord if you have questions about that stuff, or if that stuff's interesting to you, or you want to go into that kind of field. There's our Discord. Robedom, I am surprised you're still around. Robedom, I'm going to have to give you a bonus this year or something. You can't just not keep paying you, right? If you're going to be around working on stuff with us. And then we didn't go through this too much, but we'll go through this one of these days. I'm probably going to get done here because I've been going for quite some time here. I've been trying to be pretty available for you guys. You know, I've been trying to get down there on Discord and talk shop quite a bit. If the labs work well for you, we do have a book on the labs. Somebody bought the book, so that's kind of cool. Did somebody do the book? Oh no. Oh, looks like Robedom beat me to the book. There is a book. It just goes over the labs. It just acts as a, think of it, if you will, as a, you can think of the book as a journal to kind of make you think about stuff. When's my doctorate program starting? It starts on Wednesday, technically. Actually, Thursday is the first day I can post in the class. So I am starting a doctorate on business administration with an emphasis in quantitative analytics. So if you guys see me pulling up this a lot more, so if you guys see me pulling up my Spider idle and doing some of my stuff with a minor in PTO, yeah, you guys get paid in crumbs. That's pretty much it. Dr. Scoot, yeah, that'll be Dr. Scoot. If you guys see me pull this up sometimes on stream, oh, I had my game thing open. Against Great Darkness was the game earlier, in case you guys were wondering. Kind of fun little game. I don't think I played it on stream too much. Did I play a little? Yeah, I did. All right. Where's my? Could have sworn I just opened up Spider. Give me a second here. Quite sure I told Spider to open. Hold on. Now it's opening twice. Thanks, Spider. But if you guys see me pulling this up on stream more, especially when we're kind of messing around with some of our... Do I not have... Oh, that's annoying. I don't even have the most recent... Oh shit. Oh, man. I had my stuff that I had done for... Oh well. What can you do, guys? What can you do? I'll be in there more in the future, and you guys will have fun in there, I'm sure. Yeah. But what else are we working on? Yeah. So the goal for today was to get you guys thinking about this in a Socratic thought process. So the Socratic method, people think of it as just asking questions. It is asking questions, but that's not all it is. The Socratic method is also kind of a back and forth in engineering and in teaching, where, you know, I make you also ask yourself questions. Can you do these things? And then as we go through them, you end up learning more because you were asking yourself a question and then you put that in that slot of what you were talking about. So the Socratic method, the other Socratic method that I'm not allowed to do, and Robodom knows this, is I'm not allowed to take you guys out to the surf and hold you under until you want Linux as much as you want the air, right? That's an old Socrates thing. If you're not familiar with that, it's kind of pretty funny. But yeah. So we're doing that stuff. Discord is always available for you guys to hang out and talk shop in. And what else do I have? Yeah, I'm probably gonna hop off of here and play around on my computer some more. Probably start working on my dissertation. Well, not. Let me be clear. I'm not working on my dissertation stuff yet, but I will be working on my dissertation stuff sooner than later. So if you guys see me doing that in the future, I will also be doing that. Let's go find somebody to raid. I'll go hit up the streaming default. Oh man, I appreciate that, Quartz One. You guys don't have to do that, but I do always appreciate when you guys help out. And oh man, I went to my streaming default. I didn't even realize I had popped up on stream here. I meant to go to my end of stream. So there we go. Do all the Linux. I need to do more of these, by the way, where I do more of like the. Some of you guys haven't seen intermission ever before. Intermission just tells you to go practice your loops. But man, you guys are the best. The goal, yeah, Skull Crusher. I'm trying to figure out better ways to just pound this into you guys, right? Like I've been up here talking for like a couple years, but I don't want people to think I'm doing magic. I want you guys to know that you guys can do this stuff too. So the goal of all of this stuff is to get you guys to, do all the Linux, right? Do the stuff, practice the stuff, get better at it. All right, let's go find somebody to raid. There's got to be somebody out there that wants to get raided real quick. So let's go find somebody that's out doing technology type stuff. Oh man, my best friend's on. No, he's not my best friend, but he is one of the best guys around. If you guys don't follow Midnight Simon, you really should. We're gonna raid him, and I'm gonna tell you guys thank you very much for hanging out, and let's keep doing this. Let's keep getting our stuff better and getting better at this stuff. Take care, guys.